go just like this and see how far we have to go before we can actually find the files. In this case, before we solve the lab. Okay, so there it solved it. So it goes back to the root folder, and then it goes forward into this file, and then it'll go forward into the password file, and it pulls down for us information that we should not be able to have access to. And so for us, this should solve the lab for us. So each one of these just goes back one file, and it goes back until it hits the root folder, and then it'll go forward into this directory, into this file. And that will give us information that we should not otherwise have access to. Okay, we are ready to go ahead and solve our second lab on path traversal. So you can go ahead, I think with what you have learned so far in the very first lab, you should be able to solve the second lab on the directory traversal. So if you want to go ahead and give it a try, you can open up the lab, which I've already done. And you will be looking for the same file we were looking for last time, the etc password file, and that will solve the lab for you. And so you can go ahead and pause the video now and see if you can solve this challenge. Okay, how did that go? Hopefully you were able to solve it without any trouble. If not, we're going to go ahead and walk through it now. We'll go ahead and turn on our interceptor, and we will click one of the view details just to make sure we can pull down the same GET request we had last time, which was not the product ID. It was the image file name. So we'll go ahead and send that to repeater. And while we're over here, we're going to start out just the same way we did last time. We're going to come in here and start with our etc password. And then as necessary, if we need to, we'll go ahead and add in the dot slashes. But we always start at the beginning and go forward go backward if necessary. So we'll go ahead and send this. And it came back on the first try. So hopefully you were able to solve that challenge, because they're going to get a little more challenging to do manually, but not all that difficult for us. Okay, we are ready for the third challenge that we're going to be looking at for the path traversal. And this one, we're actually told what's happened. So go ahead and open up this lab, and we'll see our instructions here. And we're told that the sequence is stripped away non-recursively. And so what we will have to do is modify the attack just a little bit, and pretty regularly, especially with cross-site scripting, you will see developers that know of a way or maybe a few ways that an attack can be performed. And so they'll just go ahead and strip out just specific elements or sequences within an attack or a payload so that they won't go through. But there's almost always another way to pull this off. And so actually in this lesson and the next one, we're going to be able to observe just how you change payloads. And really in bug bounty hunting, what you're going to be doing is a lot of trial and error until something works. And so we'll go ahead, open up this lab, and once you're in here, you will click View Details after you've turned on your intercept. We'll go ahead and turn that on. And my son would think this is the coolest toy ever. And so we'll go ahead and view the details. We'll get our GET request that we need right here. We'll send it to repeater. We'll turn the intercept off. And once we're in here, we'll go ahead and we can start out with the etc password. And then we'll send this, and it comes back with a bad request. And so you can go ahead and try going back, and it comes back with a bad request. And I actually know what is going on because we're told that the traversal sequence is stripped away. So what we'll have to do is try something different. And so what you can actually do is go 4 dots with 2 slashes. And then this is going to be a different process in pulling down the etc password file. So we'll send this, and then we will 1, 2, 3, 4 continue going, and we are able to find the file we need. Now, when it comes to remembering all of these different ways that you can try and find a directory traversal, it is not necessary to try and remember these. I'm going to show you a tool that actually does all of this for you with hundreds and hundreds of different ways to pull down an etc password file. And so I'm just showing you manually how this works so that you know what's going on and you know how to find these, just in case you're not allowed to run a scanning tool or anything like that on a specific web application. But you do not need to try and remember all of these different ways to pull down the etc password file, because you will have sources available that can do it for you or remind you exactly how to pull off these attacks. Okay, we are going to be working through our final path traversal before we look at how to do this with the automated tool. And so you can go ahead and open up this lab, and in here we can read our instructions and exactly how to pull this off. And so we're told that this has URL decode in it. And so this is actually very similar to a exploit that was pulled off, and I came across this not too long ago when I was looking through path traversals and how they were pulled off on the Hacktivity. And so this was done June 9th, 2018. So quite a while ago, a couple years, but this is going to be pretty much the exact same exploit we're going to be doing in this lab. So just to show you that these labs aren't just theoretical, but they actually do help you perform these exploits. And so you can see here, this is the URL encoding. And so a simple way to look at URL encoding is you can come over here to the decoder, you can type in some gibberish, and then you can encode it as URL, and you will see the URL encoding pull down here. And so what we are going to be doing is doing something very similar to what this guy has done here. And you can actually see he actually pastes, it pulls down the file that he should not have access to. So what we are going to do is come in here, you open up the lab, click access the lab, same as we've been doing in the last few lessons. We'll open up burp, turn on the intercept, and we will view details of one of the files. We will look for the get request with the image file name, send it to repeater. And now what we're going to do is very similar to what we just saw. So we'll start out just like normal. You can go ahead and send this, and then we are going to type in the URL encoded version, because it's going to decode it for us, which is %252F, and that should pull it down for us. And we'll go ahead and delete that because it's encoded in there, and so we can send that. I'm going to do, rather than type this, is I'm going to go ahead and copy it and then paste it, and then send it, and then paste it, and then send. And there we found the file. And so you can actually really easily see how this is very practical. Here we're practicing it. Here someone actually pulled it off on a live website. And so if we come in here and we turn our proxy off, we should solve the lab. And so in the next lesson, you are going to be required to open up JuiceShop, because this is the URL we're going to be using to pull off the attack on our automated tool. So you can go ahead and open up JuiceShop and get it running. Okay, we are going to be looking at the automated way to find directory traversal exploits. And so you can go ahead and open up a terminal and have JuiceShop open and running. And just to make sure you have the tool installed, you can come down to your terminal and you can type in sudo apt get install should look exactly like this. And then you will hit enter. It will require your password, and you can go ahead and type that in, and it will run, and it might ask you, are you sure you want to install? And you can press Y and then hit enter or return if you're on a Mac, and it will install. And so the way to run this tool is very, very simple. You would just type in .pwn, and then we will give it the parameters that we want it to follow. So we'll just type in .pwn, and then we will go -m. And this is, I actually already ran it just to make sure it would run on our local server. And so this is what you will type in. You will type in .pwn, and then you'll flag m, HTTP, and then you'll flag h, and it's our local host. And so I actually just came up here and copied and pasted the page I was on. And when you hit run, it will run for us. Oh, it did not run for us because we have to run it as sudo, as our super user. And now it is running, and it'll ask us, press enter to start the testing, and then we'll go ahead and hit enter. And now you can see, look, it is running all of those for us with the //, and then it encodes it, and it just runs through, and it tells us even where it's vulnerable. Now this web application is vulnerable. I think it's vulnerable to all of them. They did not do a good job when building the web application for making it secure to this attack. And it will run, and there are hundreds of different ways to send. There's the one we just saw with the %252F, and it runs it for you, and it'll tell you. For us, it would have been right here. We would have had 3 paths to go back before it goes forward into the Etsy password. And so it would have found it right here. It would have flagged it as vulnerable. So now you can see just how easy it is to run this with this tool. And you can go ahead and hit Command C to close out of it so that it'll stop running. And it might have actually went ahead and solved a challenge for you. If it didn't, you can go ahead and type in // really any of these, because it says it's vulnerable to them, and then type in etc/password, and it should pull down. I think I already solved the challenge. It should pull down that we have accessed a file that you should not have had access to. And so that will solve that challenge for you. It's pretty simple. Running this tool is really easy, and it takes a lot of the manual testing that we just did out of account for us, and it will run hundreds of different ways to find a path traversal. Okay, we're going to start by looking at the XML injection at this point, and we're going to start a really easy XML injection. This is one that you're going to see that's probably the most common. And then from here, we're going to look at some more uncommon XML injection methods, but they're going to be a lot more severe. And so this first one is really simple. You can go ahead and open up this lab on Portswigger right here. And I want to walk you through, we'll go ahead and click Access Lab. I want to walk you through what is happening. So when we look at this XML injection, I want to focus just on these 2 lines. When you see this XXE right here, we can change this to be anything we want, and we see it down here. It is the same thing. This is the XXE being called and telling the XML file that we want it to do something right here. So we're going to tell the system to open up the Etsy passwd file. And so I will show you what this looks like. When you come up here and you click View Detail, we will need to turn on Burp and forward this to Repeater. And we can now turn this off. And we're going to need this right here. So we can copy, and we'll paste it in right here at the top. And now we're going to delete this first part right here, and we're going to change, we can leave our, I guess we'll leave our doc type as foo, and we're going to change this right here to Etsy, and this right here to passwd. And then down here where it says the product ID, what we're going to do is we want to call this right here to tell the system we want it to do something. So if you remember what this looked like over here, we have the and XXE with the colon. We need burp, and where that product ID was, we can paste this in. And now we'll send it and see if we have any errors, and we do not. And it provides for us the Etsy passwd file. This is a pretty big vulnerability. This is something you shouldn't be able to look at. This is something you shouldn't be able to look at, and it will give us users that are on the system. So from here, we're going to move on to TryHackMe, and we have a Juice Shop, which is a really great place to practice a lot of web application vulnerabilities. And we will hop over here and pop open a machine, and I'll show you a file upload XML injection. We'll come over to OWASP Juice Shop. You will need to click on login and create an account. So I'm going to create an account, and then we'll be back at the home page, and I'll show you where to start from there. Okay, so we are all logged in, and we are now at the front page. We'll come up here to the 3 lines. We're going to say we want to file a complaint, and we'll just say a bunch of gibberish. And now we're going to need to upload a file. So we will create our XML file by coming over here and gedit, and this is what we'll just name our file, so that way we know what it is. I'm going to make this on my desktop so that it's easy to find. And now we need our code to inject with, so we'll copy this. We can move it over here to our file, and then we'll just change this to Etsy passwd and save it, close it, and come back over here to Juice Shop and click browse. We go to our desktop. We want all files, XXE, open. We need burp to intercept this, so we'll come back to our proxy, intercept, and submit. Send this to repeater. I actually don't remember which one this is, so we're going to send a couple of them. We'll send this, and we'll just turn repeater off and hope we got it. So it says we've solved several of the challenges. We'll come to repeater. We'll go back here to the first one. We'll send it, and right here is the passwd file. It doesn't come back in quite as nice a format as our original one that we had done on Portswigger here, but we have the XML injection worked, and we have the passwd file, and here's the root user. So this is a file upload XML injection, and now we're going to cover a XML injection that's going to lead us to remote code execution. And you can actually see right here, they tell us remote code execution. If we are lucky and the PHP accept module is loaded, we can get remote code execution. And we're going to go ahead and try this, but this is on HackTheBox. And if you don't have a subscription to HackTheBox, that's okay. This would be something I have never seen outside of HackTheBox, but it's something to be aware of. So we'll go ahead and I'll open up HackTheBox, launch the box, and get all set up, and then I'll walk you through an XML injection with HackTheBox. All right, I have popped open here for us the HackTheBox machine. This is the landing page, and if you run a Dirtbuster or FUF, you will find this db.php, and then we have the portal.php, and we click this, and we are brought to this page. Now, if we go to test it, grab our interceptor, and we just put something in here, and we send it. We'll send this to repeater, turn this off, send, and we have this value right here, data, and this is what we get back. We have this data parameter right here. We can copy it, come to our decoder, and we can decode as URL, decode as base64, and we see we have this XML. We get an XML return that has been base64 encoded and then URL encoded. And so what we can do with this is try and add to it or adjust it and see if we can pull off an XXE attack by just reversing this. We can add in our own payload, and then we can encode it as base64, then URL encode it and put it back into the repeater tab right here. So what we'll do is come over and we'll just try to pull down the etc passwd file first. Okay, one other way to look at this that is a lot easier, rather than just coming into the decoder and decoding this as URL and then base64 to get to the XML file, is we can go to our repeater, and remember we have this data here. We can come over to our inspector, and then we can click this little arrow right here, and it will automatically decode this for us, and we will land right here, and we can actually do our changes right here, apply changes, and resend this and get our our response brought back to us. So what we will do is come over, we'll go to OWASP, and we will grab the XML right here, the XXE. We'll open this up to grab our payload. This is not the one we were in earlier, but that is okay. So what we will grab is the doc type and the file system, and we'll stop right here. We can copy this. We'll put this on a new line right here. We'll actually try to see if this will let us put this all on one line so that it looks better for us. Now that we have this on, well, not one line, but it's a little better. Here we go. There we go. Now it's on one line. So what we're going to do is similar to what we've been doing before, is we can just leave this however we want. We're actually going to delete this. We don't really need that, and it looks a little better for us. This goes on a different line. Guess we'll leave it. Okay, so here we go. What we can do at this point is type in etc/passwd, and then down here we need to call the XXE. So we can go our and symbol, XXE, and our semicolon, and apply changes. And if we send this response, you can see right here we have the passwd file brought down for us. And so one of the things we always should look at, especially when we are on a Hack the Box, some kind of CTF, or even a pen test or a bug bounty program, you really wouldn't do this, but you would look for the users, because you may be able to attack some of them. So we have the development user, here's the user ID, we have root obviously up here, and what you can do is just look for the ones that have bin bash, and those are the ones that will have a shell available on them. So we have development and root, and a quick look, I'm not really seeing any others. And now what we can do is try to pull down that db.php file, but in order to do that you will have to use a PHP wrapper, and those are something I would suggest learning, because you will see them every now and then whenever you see a PHP system running. A lot of times you can think PHP wrapper and see if you can pull down information that you should not be able to. And there's a lot of different places you can use those PHP wrappers, but one of those places is going to be right here. So instead of pulling down a file, what we're going to do is we're going to type in here PHP, and we can delete all of this and type in filter/convert.base64-encode/resource equals. And instead of the etc passwd file, what we're going to be looking for is the db.php, and you can find this typically if you're familiar with doing CTFs or any kind of pen testing. You will know that you can find the files you can find the files for a web application inside of var/www/
/html/db.php, and this is pretty standard for where you're going to find files on a Linux system, and we can apply changes. We can copy this, we can go to the decoder, paste this in, and as we decode it with base64, it tells us that we have this in our response. So this would be what was brought back with our PHP filter, and we have a username right here. We have the database name, we have a password right here, and we should be able to SSH in as the development user using this password right here, because we know it's really common for people to reuse their passwords, and this will actually lead to remote code execution. So if we come over here and we say SSH, and then we say, make sure we had that user right. I think it was development at 10, 10, 11, 100. We might have to grab that user again. We'll say yes. And come over to the decoder, grab the password, and paste that in. And it worked. So this is how you can get remote code execution on the box on a server using XXE. And so with that, this one was really complex, but XML injection is something you should look into and try to learn. I would suggest going back to Portswigger and maybe practicing a few of their XXE challenges as well as Juice Shop, and just play around with it until you feel like you are comfortable and you understand what is going on. So there are 3 different ways that you can use XXE in the cybersecurity testing world.
Okay, one of the most common vulnerabilities is going to be cross-site scripting, or it's also known as XSS. And this vulnerability is common, but it's also going to be pretty hard to exploit without knowing some form of HTML and JavaScript. So there are basic payloads that you can go in and you can just test a bunch of them. And I'm going to show you a list that I found. It's got over 6,500 different ways to try and exploit this, but most of the time you're going to have to inspect the page and modify the content. But we'll get to that in just a little bit. I'm going to show you just a couple of cross-site scripting examples here, and then I kind of want to show you the code of what's going on. I think you'll be able to understand it even if you know zero programming. So with that, we'll go ahead and I'll show you an example of what cross-site scripting is, and then I'll explain why it's so dangerous. And so this is going to be the most basic, simple form of cross-site scripting. And so all we want to do is have an alert pop up. And if you can pop up an alert on a bug bounty program, you will be able to submit that for a vulnerability. And there you'll see them a lot of places. A lot of people like to look for them. I don't really look for them all that often because I think most people look for these, and if it's not stored cross-site scripting, then you're not really going to get paid for the amount of time that you put in. You'll get paid, but just not enough for the amount of time it's going to take to find them. So we're going to do this with an image tag. So we'll go image source equals, and then we leave it blank. And when this is blank, it's going to make an error on the page. And so on error, we want to alert, which is going to give us the ability to pull off the cross-site scripting. And we're just going to alert 1, and then we will close the tag. And I have made a mistake somewhere. Let's go ahead and delete this equal sign. There it is. So we have the alert pop up and it says localhost 1. Now what you can do with a cross-site scripting and why it's so dangerous is not because you can just pop things up on somebody's screen. But what you're able to do is you could make this look really fancy, and you could say log into a Wi-Fi or log into this page, or you were accidentally logged out, and people can type in their username and their password, and then all of a sudden you have their credentials. You can put alert document.cookie right here, and then all of a sudden you can steal their session. And so there's quite a few different ways that you can use this to get malicious with it. And so that's why it's so dangerous, but it's also really common. It's going to be in the top 10 vulnerabilities that you're going to find on pretty much any list. And so right here is a different version. So right here is just plain as can be. You can type whatever you want and nothing's going to get blacklisted. So right here, I have made a little, it's really short. It only has the image tag, but you can type your script. The image has been blacklisted. So what I mean by that is if you watch what happens, I finish typing image and it automatically deletes it. This will happen on programs that you're going to test. They'll have characters that are blacklisted. I come across it regularly. I have come across blacklisted characters when I was trying to do a SQL injection. So you'll come across blacklisted characters. What you'll do is you can go out and you can find encoders, and you can encode your payloads in order to fit your specific needs. And in this case, it's pretty simple. All you have to do is go I and make a capital M and a G, and it doesn't get deleted. Or you could go capital I, M, G. And this is a way that you'll find, especially on Capture the Flags, to bypass blacklisted characters or words. Is you just change it a little bit, or you can encode it and you can bypass the filter. And so we could do the exact same thing that we had done before. So we'll go on error equal alert, and then we'll just do alert 1, and then we'll close it off. And there's the alert. So all we really had to do was just change the image tag, because the image had been blacklisted, but we were allowed to pull up a different version of the image tag. And so what this looks like, here we have banned characters. So you can have banned characters such as these. People will ban these characters so that you can't inject your code into it. But I will show you. So in this case, I actually ban this character, the backslash. So no matter how many times I push it, it's not going to come in. But you can still ban this. You will find the backslash ban, because if you can't close a tag, then it's going to be really hard to pull off a cross-site scripting. Not impossible, but you can still do it. So what this looks like is I am just replacing the image with an empty string. And over here we have the banned characters. You can see right here, you're not allowed to use those, and I replace them with an empty string. And so this is what a blacklist would look like. You just have a bunch of characters listed that are blacklisted, and you're not allowed to type them in. So when you have a banned backslash, which you're probably only going to see in Capture the Flags, something like this. But what you can do is you can actually make a button tag like this. If I can get that right, there we go. And then you can just type something in here. And then what you can do is you can type in on click equal, and then you do the same thing. You put your alert, and we'll put our 1, and we don't have to have a closing tag. We don't have to close that. So we click it, and there's the alert. And you will see this in one of our practice, when we practice the cross-site scriptings. So those are just a few ways you can pull off the cross-site scripting. I want to show you a page that has a ton of cross-site scripting payloads, and here it is. You can actually just Google cross-site scripting payloads, which we'll go ahead and I'll just do it right now and walk you through it. We'll just type in payloads and just click the first one, and here's going to be a list, so you can get an idea of how many are out there and different ways you can do a cross-site scripting. And so this is why I'm telling you there's a lot of different ways to do these. We'll actually see one similar to this in just a few lessons, because we're going to have to close off a tag, and then we're going to have a character blocked, and then we'll actually be able to insert the payload. So there's a ton of different ways to pull these off. It's going to require some knowledge of HTML and JavaScript, or you can, if you're on a capture the flag, you can just go to a burp intruder and you can just send this entire list until you are able to receive a solved challenge. But with that, this is a basic introduction into cross-site scripting, and we'll get a little more hands-on, and I'll have you guys start practicing writing your own payloads in the coming lessons. Okay, for this challenge, I want you to come to the HackerOne or the Hacker 101 CTF. This is HackerOne's practice site for us to practice what we've learned. You can come in here to the easy with 2 flags and click go. If you would like the challenge, we have already saw the XSS in this challenge. I showed it to you in the last lesson. So if you want to go ahead and look for it on your own, you can go ahead and do that. I think you have the knowledge to solve this challenge all on your own without any help, but I will do a walkthrough here in just a second. So if you would like the challenge, you can go ahead and see if you can find the cross-site scripting, and you can do that now. Okay, once we're in here, you can go through, and one of the first things, if you remember from the recon lesson, is to click through and just open up everything in the page and just see what you can find and what you can do. I actually just thought of another way to try and solve this challenge that I might try and see if it works. And then you can come back and you can go back to the home page, you can create a new page, and you can just click through and see what you can find. But in the markdown, they actually give us a clue as to how to solve this challenge. You have this random button here, it doesn't do anything, but if you edit this page, we have the tag for a button. So if you were unable to find this, you can go ahead and try and solve the challenge now. Because if you remember, if we have a button, we can come in here and we can go on click, and then we can put in our alert, and then we can put in 1. And so we have our on click here, and it's closed off, and we should be able to save this. And on our click, we are given the alert. I just thought of, I bet we could copy this. There's another way you could have solved this. If you didn't see this button here, and you didn't have this clue, but you came into the testing and edited, and you saw this, you might have thought to go ahead and just insert your own button, and you could have pulled off the same thing just on a different page. And we'll go ahead and change this to just click, just so you can see it's a different button on a different page, and we could have done the same thing. So that is another way that we're able to pull this off, and we're going to see a couple of more examples. And the reason for this is the cross-site scripting is a rabbit hole that you can go down indefinitely. There are thousands and thousands of different ways to pull this off. And so I just want to show you the basic introduction into cross-site scripting, because without knowing HTML and JavaScript, it's going to be kind of challenging to pull these off. And since this is a beginner course, I'm not really expecting any software developers to be in here wondering how to do a cross-site scripting, because if you're a developer, you're going to already know, because you will have had to write code to defend against it. Okay, we are going to come back to Portswigger, and we're just going to do a few of these just so you get an idea of how cross-site scripting works and how people can attack it, and just a little more understanding of seeing these in context of how they relate to pulling off these vulnerabilities, especially to beginners, as you can just copy and paste some of these into search engines and search bars, and you will see them on HackerOne and the Hacktivity, and just so you understand what's going on. So we'll go ahead and open up this first lab here, and we will be told what we are supposed to do. So we're supposed to call the alert function in order to solve the lab. And this one is going to be one of the most basic cross-site scriptings that we're going to see. And one of the common ways to check to see if a website or a web application has any defense against cross-site scripting in a search bar like this. What you can do is you can come in here, and this is basic JavaScript. So we just type in script, and then we type alert 1, and then we close the script tag. So this is just a basic JavaScript command here I can type. And so if this has no sanitization, then this should work. And you can try these in search bars. You can try them and post this script to any kind of social media outlet for the web application and see if it pulls back any cross-site scripting. So we'll go ahead and search this, and it says we have timed out because I opened the lab before I started this video. So we'll go ahead and reopen the lab and let that load. And we'll go ahead, and once this is loaded, I will actually just paste that in. Go ahead and paste that in, and we'll search it. And it pulls back the alert. We were able to alert 1, and it says we have solved this challenge. Now in the next challenge, we are going to go over the DOM cross-site scripting, which I actually think is down here, because this is one that we have seen with the inner HTML, this one right here. So if you would like to go ahead and open this up and give it a try and see if you can get this to pull the alert, we have looked at this payload before. It's not new to you. You will have seen it. You can go ahead and try and find it on your own. Okay, so how did you get along with that challenge? So we can actually come in here. This is the lab we're going to be working on. We can open it up, and we're going to be setting what we type in to the inner HTML, which means what we are typing in and searching for is going to be saved on the client side, which means it will try and render it. This is what I set up when we looked at the very first examples on the application that I tried to give you examples. If you go back and look at it, this says dangerously set inner HTML, which is just inner HTML with the React framework. And so this is going to be the exact same type of vulnerability that we have already witnessed at the beginning of this section on cross-site scripting. So you can go ahead and open up the lab, and we'll have our search bar, and we're going to be doing essentially the same thing we did in the beginning, where what we type in is going to be rendered on this page. And so we can type in our image, and then we'll do our source, which is where it's going to look for the source. You can actually type anything in here. And so it's going to look for a file saved within this application with this name, and it's not going to find it. And so that's going to cause an error. And what do we want to do? On error, we want to alert, and then here you would put your proof of concept, because we just want to prove that this works. And you can type in XSS, or you can type in 1, or you can type in whatever you want. And we will go ahead and close that off, and we can search this. And there is the alert for us. And so with that, that solves this lab. And we're going to try one more, and I'm going to show you kind of, this is a little more towards the intermediate level of cross-site scripting, but it's just a way for you to know more about cross-site scripting. And if you come across it and you really think there is a cross-site scripting vulnerability in a website, just how you can work through that and maybe do some more research on your own to try and exploit it. Okay, this next lab is going to be one that is going to give an example of what it looks like to start looking for cross-site scripting in a little more of an intermediate or advanced way. This is going to be probably the most common way that this is going to be found, because you're going to have to inspect the element and know how to break out of the HTML or the string that you're stuck in order to pull off JavaScript and run it within the application. So we're actually going to go ahead and open up this one right here, and it'll be over here. It'll tell us what we need to do, and we just need to break out of the JavaScript string and call the alert function. So I went ahead and opened this up, and the most common way to do something like this is type in something that you can remember what you typed, or something really easy to find. So we'll type in 1, 2, 3, 4, and we'll hit search. And now what we'll do is inspect the element, or you can view page source. We'll actually do that. That'll be a lot easier to see. So we'll view page source, and then we find our 1, 2, 3, 4, 5, but this is not where we're going to be breaking out of this. See, this is a script tag. The search term right here, we searched for 1, 2, 3, 4, 5, and we have the closing script tag here. So in order to close out of this, we can actually put a script tag up here in our search query, and it will close all this off. This script tag will match this script tag, and then we should be able to open up a new script tag, and it will run in the order. It'll run all of this in the order that it is laid out, and then we should be able to put in our payload. So we'll come back to our lab, and what we should be able to do is close off the previous script tag. So that will close this tag, and everything before it will be inside that tag. And then we should be able to come in here and type in our own payload. And so we'll go script alert, and we will just alert 1, and then we can close off our payload. And look at it, make sure it looks right. And that should work. And then we'll go ahead and search it, and there is the alert, which means we've solved the challenge. And everything after that script tag will get rendered on the page because it doesn't have an opening tag, if you're wondering why this showed up. So we'll go ahead and we'll look at the page source, and I'll show you the difference. See, here is where we closed off that script tag, and then here we put in our payload. And then because this script doesn't have an opening tag, this just gets rendered on the page as plain HTML. So if you are unfamiliar with programming, this probably doesn't make a whole lot of sense to you, but when it comes to cross-site scripting, it's kind of going to be necessary to understand HTML and basic JavaScript in order to pull this off. But the reason I included this in this beginner course is because cross-site scripting is one of the most common vulnerabilities, and so I wanted you to be aware of it, and maybe you can practice it and see if you can get better, or if you want to, before you take the intermediate course, is go learn some basic HTML and some basic JavaScript. It won't take long. You can learn HTML in a week. You can learn CSS, which is how to make a website look pretty, in a very short amount of time, a couple of days, and then you can learn basic JavaScript probably in another week. It doesn't take long. It's pretty simple to learn. And so I wanted to show you cross-site scripting. I want you to be aware of it. Like, look at how many cross-site scripting labs exist on Portswigger, and I think they actually have, DOM vulnerabilities, so even more cross-site scripting. So there's a bunch of cross-site scripting. It's really common, but it does take some programming knowledge to solve. And so with that, I will see you in the next video.
Comes next is usually the question of what kind of programming do I need to know. So in this video, what we're going to cover is the Python that I think you need to know as you're entering into cybersecurity. This is an introductory course into Python for the purpose of cybersecurity. I have tried to keep it as streamlined as possible to keep you away from having to watch a 6-hour course on Python for cybersecurity that is just full of stuff that I think you're not really going to need in the future. So this is a beginner course, and if you have any questions as you're going through it, please leave some questions down in the comments.
Decided to go ahead and show you guys how to install PyCharm on your Linux VM. If you have a Mac or Windows, it's really straightforward. You just go to the JetBrains, you download PyCharm. I'll have this link in the description, and you'll click Windows, Mac, or Linux, and then you'll just hit download, and it will automatically start to download unless you're on Linux. So I have had to do this for several virtual machines that I've had. It won't download, and so what you have to do is right click the direct link, and you'll copy link. Then you will go to your terminal, and you'll run a wget wherever you want this file to be saved. So if you want its own PyCharm folder, put it in its own PyCharm folder. For me, it is in my downloads, and you can save it wherever you want. You'll hit enter. This might take a little bit depending on your speed, your internet speed, and then you're going to unzip it wherever you downloaded it with this command right here, and then it will unzip. A bunch of files will come out, and then you will be able to CD into the folder. So for me, I will CD into my downloads because that's where it is, and then I'll go into PyCharm, and then I'll ls inside here, and I'll go into my bin, and then this is the executable I want to launch in order to launch PyCharm. So I will type in bash, and then I will type in pycharm.sh, and it will automatically launch PyCharm for me. So this is how you get PyCharm on Linux if you are wanting it on your Linux. I usually write everything on my Mac, and then if I need to run the code over on Linux, I will pull it over to my Linux machine and run it over here. So with that, we will get started in the next section. All right, we are ready to start our Python course. So we're going to start out very simply with a string. A string is a sentence that is a data type. So we're going to have several different data types coming up, but a string looks very simple. It is what I think of as a sentence in English. So you just have hello world. A string is always going to be stored inside of quotations. So if we were to print this, it would print right here, hello world for us. And if we change it, it's going to change along with us. So this is really simply, this is a string, and we can store strings inside variables, which is going to be coming up in the next section. But first, before we go on, you will see sometimes that you need a string on a new line, especially if you're going to export something into a CSV file. You're going to want things on new lines, and at the end of your string you can type something like this and then say hello world number 2, and then we can print this and we have hello world and hello world number 2. And if I wanted to get rid of that space, I would do it this way. So we have hello world and hello world number 2. Another way to go about printing this would be like this. So print, and then we put our quotations and we say hello, and then we can add this like this, hello world, just like that. And now if we were to print it, we have hello world number 2, and then hello world. You see how there's no space right here? This is something that I run into regularly, and I just had happen the other day. There's 2 different ways you can put a space right here, and I'm going to show you the easiest way first is just to add a space right there, rerun it, and now you have a space. But I think it's helpful to know more than one way to do this. So you can add another quotation and put a space in there and add another plus sign. So you can run it this way and you still have that space. And it's really important to know this right here, because sometimes you'll be running a for loop and everything is just smashed together and you want a space in there, and you can add spaces simply just by doing this. So what I'm showing you right now, you may be thinking this is not ever going to be helpful, and I wouldn't be showing it to you if this wasn't helpful, and it's something you're going to run into in the future. So this is a very streamlined course, and I'm showing you just what you need to know in the world of cybersecurity. Now we're going to be covering something called a variable, and a variable holds the place of some kind of data that we're going to want to use later. So we'll go ahead and comment this out, and on a Mac it is command and then question mark. And so we'll comment that out. So now if we run our program, there's no output. And we're going to look at a variable. So a variable can be something like this, name, and then the name Jim. This name is going to hold whatever is right here. So this is our variable, which is going to represent the name Jim. So if we come down here and we print, and then we type in name, and then we run this, it's going to print what is stored inside this variable. When we look at variables, one of the things you're going to want to be able to do, especially in the world of cybersecurity, if you ever want to write your own tool, is you're going to be saving variables, only they're going to be input variables. So if we were to go like this and we say name equals input, and then we type what is your name, and then we'll want a space right here. So when we type in the prompt, it has a space. We'll comment this out, and then we'll print name. So we're going to print the variable, whatever the user inputs here. So now we can say, what is your name? And we can say Tom. And when we hit enter, it prints Tom. And there's something else that's really cool that I use all the time. It's called an F string. And what you do is you add an F at the beginning of your string, but you can print variables inside your string. So we'll go ahead and put name inside here. And so we can say hello and then the name. So we'll say run this. What is your name? Tim. And it puts out hello Tim. So this is an F string. This is something you're going to want to know. This is something I use all the time. And in the next coming up videos, we're going to look at data types and how we can pull information out of a specific string. And this becomes really useful whenever you run a script on a victim machine or on your target machine or your target server. You may get a lot of output that you don't really need, and this is a good way to start extracting data. So we'll start that here in just a moment. Okay, it is time to draw out some information from our string. So what we can do here is we can save a variable, and we'll call this variable name, and we can put inside of our name Tommy. So we have Tommy here, and let's say we want to grab just this M right here. What we can do with this is we can say print. We want to print our name, and then we add some square brackets just like this. And when you're running Python, it always starts at 0. So it goes 0, 1, 2. And so that first M is going to be 2, just like this. And so if we run this, it's going to print that M for us. And just to show you, if we want to print the T, we would enter a 0 here. And this is one of the most basic ways to draw out information. And it's going to get a lot more complex as we go, but this is what the square brackets do when you see them. And when we start to tackle lists and arrays, these square brackets become a really useful tool to remember. So as we continue to go through this, I want to pause right here, and I want you to go ahead and play around in your own text editor and make some print statements, make them on new lines, add in some spaces, make some inputs, and actually practice gathering information, and maybe have 2 or 3 inputs and have it print things back and forth, and you have a little conversation with your text editor. So I want to go ahead and give you this challenge for you to go ahead and play around with the things you've learned so far and try and really ingrain this information into your mind. These are the foundations of Python programming, and you need to know and understand how they work. You're going to notice is you can name variables whatever you want. And I name my variables really poorly, mostly because the programs I write for myself, and I am not working with a team of developers, but maybe you will someday. And when you name your variables, you can name them whatever you want. And you'll want to make them names so other people can understand what is going on. So if you look at some of the code I've written in past videos, I do this right here. I name everything like this. And it is not really the best way to go about naming these. So I'll name one guy 1, and I'll go guy 2, and he'll equal Bob, and then I'll come down here and I'll print guy 2. And then I run this, and then I have Tim and Bob. You can name variables whatever you want. Literally, you can go whatever I want. And you can make this a variable, and then you can come down here and you can print whatever you want right there. And you can name variables whatever you want. So I would recommend getting in a good habit of making your variables something that you can recognize. And it's a very bad habit that I have, because I make my variables so that people cannot read what I have done. So this is something I'm trying to get better at, but I probably won't, because this is a bad habit that has formed over many years. But I want you to have a good habit of naming your variables something that you can understand and other people's can understand. So as you go through and work through your challenge, try to name your variables different things that you will be able to understand in 6 months after you have written a program and you need to go back and edit it. Okay, I have created this little challenge here for you. If you want, you can go ahead and pause the video and open up your text editor and see if you can create this little program right here. So we want to, 1, create an input with a greeting. So just say, hello, what is your favorite food? Let them put it in, and then take another input and say, what is your favorite hobby? And store that also in a variable. And then we're going to print with an F string their favorite food and their hobby. So if you want to give this a go, you can go ahead and give it a try. If not, we will start it now. So we're going to start out with create an input with a greeting. So we'll just say print hello. And then we're going to take an input, but we got to save it as a variable. So we'll save this as food, and it's going to equal an input. And inside the input, we're going to have the question, what is your favorite food? ? question mark, space. I see that we have a typo here on all three. And then that's going to be saved as their food. Then we're going to say input, and this is going to be, we'll just save this as hobby. And we're going to take in input, and we're going to say, what is your favorite hobby? Question mark, space. And then we're going to print with an F string all of this together, and we'll say print your favorite food is, and then if you remember, we need our F string here, and we should grab our curly braces and say food and your favorite hobby is curly braces hobby. Now when we run this, if we did everything right, it should print for us this final statement after we give these inputs. So we say run, and it says hello, what is your favorite food? And we'll just say chips. What is your favorite hobby? Running. And it says your favorite food is chips and your favorite hobby is running. So this is a simple input form, and it's going to print out with our variables that we have stored. And this is a good practice because when you write a program for a tool maybe that you develop in the future, you are going to want to know how to do inputs, so that way you can take the input, save it in a variable, and then later do something with it. So later on in the course, I'm going to give you a practical example of taking input and then running it in a program that is really helpful, and I will cover that when we are ready for it. All right, so we have covered the string so far. This integer is a whole number, so if we say int, we have a number of 7. Floats, we're not really going to use these a whole lot in the world of cybersecurity. They have a point within the number, so 3.14 would be an example of a float. To date, I cannot remember a single time I have used a float in cybersecurity. Usually that's more towards data science or something of that nature. A Boolean is true, false. You will want to remember Boolean. We'll cover these a bit in the future. When we do our while loops, we'll be using the true, false. So these are some of the different data types, and just to get an idea of what these look like, if we save a variable and we make it a float and we say like 1, 2, 3, and then we print this, it will tell us what we have. So we can come down here and we can say print, and then we can put type, and then we can put in our variable, and when we run this, it will tell us that we have a float. And if we put in an integer, it will tell us that we have an integer, and then so on and so forth. We can do this with an int, and then we can also do this with a string. And we can hit run, and it tells us we have a string. Sometimes we will do something like this, and then we have this saved as a string here, and then when we go to add this to something else, we can get an error, and it's because we have a string and we'll be trying to add together a string and a integer, and it won't work. So we'll go variable 2 equals 3, and then when we say variable 3 equals variable 1 plus variable 2, we're going to get an error, and it's going to tell us that you can't add these together. So this is one version of how these matter. Another version of this is, let's say we want to print, and we say we have an integer right here, and we want to add it to a string, and we can go like this, and we say 70. What do you think is going to happen? It tells us we can't add these together. But if we take this and we turn this into an integer, what will happen now? Now it works. So this is the difference. So this is an integer, this is a string, unless we declare it to be an integer. And you can do the same thing with floats, so I'm not going to cover those. And then what happens if we do this right here? What do you think the output will be? And the answer is 7070. So this is the difference between integers and strings and how they work with numbers and data. So if we wanted to, we can turn both of these into integers. And this is the last example. I promise I don't want to bore you with adding these together. And then we say enter and we're back to 140. So this is a little bit of strings, integers, and booleans, and we'll kind of skip floats because I don't think we'll really need them, but it's worth mentioning so you know they're here. And with that, we will continue on with our next challenge. Okay, so we have these numbers here, number 1, 2, 3, 4, 5, saved as num1, and then num2, and then num3. What I want you to do is to write this to your console, or write this to your text editor, and then I want you to add this variable plus this variable and see what the output is. And then I want you to take the second number in num1, so it would be this 2 right here, and I want you to add it to the second number in num3, which is this 7. So your output should be 9. I want to see if you can figure that out. And then the third challenge is to take num2 and change num2 into a float and print the type to the console, so that way the console tells us that it is a float. So if you'd like to go ahead and pause and give this a try, you can do that now, or we will go ahead and tackle this right now together. So what we are going to do just first is we're just going to print, and we're going to say we're going to turn this into an integer, and we're going to go and write in num1, and then we'll add this as an integer, and then we will say num2, and this needs to be closed off or we will get an error, and this should print it for us. So it tells us here is the total if we add those together. And then the second challenge is to add the second number. So we'll just take this, just a heads up, copy and paste. In programming is always a bad idea because if I have a bug here, I just now copied and pasted it and I have 2 of them. But what we're going to do is we're going to take this and we're going to put in our square brackets. And if you remember, it says 0, 1. So we're going to say 1. And then we're going to say 1. I guess I didn't really need this. And then we'll print this. And our output is 9. So now we've grabbed the second numbers. And then our third challenge is to change number 2 into a float so that it prints float. So what we want to do here is just say print, and then we're going to tell it we want a type, and we want to print out the type of num2, and then above that we're going to just type in num2. You can do this 2 different ways. I'm going to do it this way. I'm going to say num2 equals num2, and we'll just go like this, and we'll type float, and we'll close this off. And now if we print this, it tells us it is a float. And we will continue on with our Python course in the next section. Okay, we are going to do a walkthrough of if, elif, and else statements. So this is the instructions for the little program I'm going to write. But when I finish this program, I'm going to give you a challenge to do something similar on your own. So I'm only going to give one example. You're going to need to pay attention and maybe watch this walkthrough twice, and then go on and try the challenge. So the first thing we're going to do is if you are under 5, you are a kid. So our if statement is going to first need an input from the user that is going to tell us what is their age. So we'll just say we have a variable and we want it to be an integer, and we want an input, and we're going to ask them, what is your age? Question mark, space, and we have to have that space, otherwise it's really ugly in the terminal. And then we're going to start our if statement. So we're going to say if this person's, their input, which is their variable, is less than the age of 5, then we want it to print that they are a kid. So we'll print, you are a kid. Now, one thing we want to do is if they hit the age of 5, we'll need an equal sign here. Otherwise, I'll just show you. If we say we'll need an else statement so this doesn't error out. Actually, we'll just let it error out. We'll say, what is your age? And they say 5. And we get no output because this doesn't include 5, remembering that the computer starts at 0 and then it's going to stop at 4. So if we want to include 5 in as yours a kid, we'll need that the variable is less than or equal to 5. Now, if we put the 5 in here, it will print for us, you are a kid. So what we need to do next is we're going to type in elif, because we're going to make an elif statement, and we're going to say the variable is less than 15. And the reason we don't have to worry about anything under 5 is because it will catch this if statement, and then this whole program we write after this will stop and the computer will actually skip it. So we don't need to worry about adding anything else in here. And we can say, actually, if you are less than or equal to 15, then we are going to print you are a big kid. And then for the final elif, we will say the variable, and we will say if it is greater than or equal to 21, and that's ugly, and we will say print, and we're going to print you are a bigger kid. And now we're going to put in an else statement, and in our else statement we're going to print anything that's over 21. We're just going to print you are old. So now if we run this and we rerun the program, we run it and we say how old are you, and we say 3, we get your kid. If we say 13, we get your big kid. If we say 18, we see you're a bigger kid. And if we say you are 44, we get you are old. Now, because we're going to be using this as a tool for us to be able to write tools and modify tools, I'm not going to cover this because I think that it's not really necessary for cybersecurity. But if somebody were to run this and they put in the letter A, it's going to crash our program because the letter A is not a number. It's not an integer. So what we'd have to do is we would have to make this so that if they put this in and it was an A, it would print, enter a number, and then rerun. But we're not going to do that because it's not really necessary for cybersecurity. It's just something to be aware about. Now, what's coming up is your challenge. Let me delete all this and I will write up your challenge for you in the next section. Your challenge here is to take the temperature from the user and then tell them if it is less than 20 degrees, you need boots. And this is from the US, so I'm running in Fahrenheit, not Celsius. And if it's less than 30, you will need a coat. If it's less than 70, you will need a jacket. If it's over 70, it is nice outside. So take this input or take this information and make a program with if, elif, and else statements. Okay. So here is how I would go about doing this. I would take an input and it will say, what is the temp outside? And this will need to be an integer because we're going to be comparing this as a number. So we'll say if var is less than 20, then we're going to print you need boots. And we'll say elif var is less than 30, print. You need a coat. And then we're going to use one more elif here. Elif var is less than 70. Print. You need a jacket. And then finally we'll do else. And it's above 70, then it's nice out, and we don't actually need to put anything in there because this is an else statement. So everything that's above 70 will automatically print. It is nice outside. So when we run this, if we put 12, we need boots. If it's 22, we need a coat. And if it is 65, we need a jacket. And if it's 85, in my opinion, it's perfect outside. So this is the if and the elif and the else statements. We're going to be moving into for loops, and later we're going to look at nested if statements, and they'll look something like this. If it's less than 20, and then we can say if var is less than, we'll say it's greater than 25, then we can print you need boots, and then we'll print something like gloves. So nested if statements look something like this, and you can have nested if statements just so you're aware of it. So if we say it's 26, it will, because we're hitting this one, we'll say this is 15. So if we say that the temperature is 16, we hit you need gloves and you will need boots. So this is a nested if statement. We'll cover these a little more in the future. I don't know how much you will need these nested if statements. I use them every now and then, so it's nice to know that you can run nested if statements. But for now, we're going to move on to our for loops. Before we get into for loops too far, I want to show you why for loops are important, and I also want to show you why lists are important, which we're going to be going over here in just a minute after we get the basic understanding of a for loop. So this is a program. I've shown it before. Don't worry about what it looks like. It looks kind of complicated, but it's really not. What happens is you put in a repo that you would like to target on GitHub to go and search for all of the usernames, passwords, and files that just shouldn't be made to the public. So in this case, it's looking for passwords on GitHub. But what we have done here is a for loop. So this for loop right here, we have an empty list, which we're going to cover in a second, and it goes out to GitHub right here, and it will go through all these links, everything you can click on, and it's going to narrow it all the way down to the repositories, and it will click this link, and then it'll click the file, and then it will click the raw, then it copies this entire thing, and it puts it into a CSV file, and then checks for the word password. So that's the program itself. But what's important to remember is what happens is it goes out and it pulls all the links and puts them in a list. Then it goes through this for loop and it takes all of these, and it says for every one of these items that is inside of the links, which is actually this variable that I have up top, it's going to do something. So for loops are very important. You can see I have another one right here. So for loops, we are going to need them. Lists, you are going to need them as well. And I just wanted to show you this because sometimes what happens is you'll be going through trying to learn something and I'm showing you something very elementary and you are like, why do I need to know a program that tells me to put on a jacket? This is all building up to something that is going to be able to help you build tools, and more specifically, if you're new, just be able to read through exploits and be able to edit them, because you're going to need to know how to read Python and edit exploits as you grow in the world of cybersecurity. So here is a very basic for loop, and I'm going to show you it in a string because we've already covered strings. And what all this does is we have our variable string right here that is holding hello world. And so the way the for loop works is it says for I in string. So this I right here is going to be another variable that holds one letter each time the for loop runs. This I is going to represent one letter, and in a list it's going to represent each item in the list. So this will run. I'm going to run it so you can see what this looks like. The way it runs is it goes for I in string. So it's going to grab the first letter, which is going to be the H, and then it prints it. But the for loop is not over. So it runs the loop again and it'll grab the E, and it'll print just the E on a new line. And then it goes through and it runs every single time until it is out of things to run, and then it closes the loop. So this is how for loops work. I'd like for you to go ahead and write out your own for loop and maybe put something different in here and try to get an understanding of how it works. And if we wanted this to print all of this together, you would have to store this into a new variable and then print it outside the for loop down here like this. And this is where we would print our new variable. And we're going to cover this in lists because this is something that you will need to do in the future. So go ahead, play around with the for loop, write one, get an understanding of how it works. If this doesn't make sense, rewatch it, and hopefully it makes sense. I know after teaching for loops to several different students that for loops sometimes can be hard to understand, but they are really useful and something you need to learn. So we're going to be covering lists in the next section. We're going to be looking at lists, and a list is something that is going to be useful because we're going to be appending to lists all the time within our for loops. So a list can look like this. My list equals square bracket, and lists always go inside of square brackets, and we can say item 1 and then comma item 2, and then we can do an item 3. So we have our list here, and if we want to run a for loop through this list, we will say for I in my list print I. And now if we run this, it will run item 1, item 2, item 3. So this is a list. We will be using these in the coming lessons, and they will be helpful for you in the future. As you've seen in this program, I have 2 lists right here, and they are used regularly to append to. So lists is something you will need to know. So go ahead, make your own list and see if you can loop through your list, and maybe try and just print something like this later. Just print the item 2, so you'll have item 1, 2, 3, and then print number 2, and see if you can remember how to do that. If you have forgotten, it would look something like this. Print, and then we can say my list, and then we can put this in square brackets, and we'd say 0, 1, and then we have a 1, and now we could print this, and we have 1, 2, 3, 2. So that is going to be it for the lists. We're going to move on, and we're going to start using lists in a more comprehensive manner. So we're going to try a while loop now, and the way we're going to do a while loop is by using a Boolean. I like to set a variable and then set it to true, and then at the end of the while loop I will set it to false. So the way this works is make a variable, and we'll just say variable, actually we'll name it on. That's a good way to name the variable, and we'll say on equals true, and then we'll say while on, and we'll make a variable and we'll just call it variable because I don't know what to name it. And we will take an input and we will say continue running while loop, and then we will put y, we'll put a y or a no. So would you like the while loop to continue, yes or no? And then we can say that we can go do something like this, and then we can set a variable up here and say I equals 0, just so you can see how many times this is running. And then we'll say I plus equals 1, and then this should just continue to run. And then we'll put an if statement, say if the variable equals in, then we'll say that on equals false, and this will kill our for loop. So now if we run this, it'll say would you continue running the while loop, and we will say yes, yes, yes. And then when we say no, it'll kill the while loop. I forgot to print our I so that we could see this. So now we can say, would you like to continue? Yes, yes. And you can see our variable, every time the for loop runs, our I gets added to 1. So our for loop has run. Now it says 7 times, 8 times, 9, 10, and then when we're done, we can say no, and we can end it. Okay, we are going to be starting functions, and just to be clear, I have not pre-written any of the code we're about to go over, or mostly anything we've gone through in this course. That's why you've seen me make mistakes. And so as we start functions, I'm going to try and make this a little more realistic for us, so that when we are thinking through functions and writing code in the realm of cybersecurity, you can start to get an idea of how this can be used. So we're going to start with functions, and a function just calls something very specific that we want to happen. So we can just say, we'll call it my function, and then the way your function is going to start is with a def my function, and then we close it off like this. And then down here, we want our function to do something very specific. So we can say print, and then we can say it worked. And the way a function gets called is usually somewhere further down inside the code. Something happens and it triggers this function back up above it for it to actually do something. So what would happen in order to call this is we would just say my function. Now when we run this, when the computer reaches this right here, this closing bracket right here, I usually like to think of this as the call sign for the function. So if we run this, it's going to print it worked. And this will become more clear as we write more of these, but this is the basic concept of functions. And one thing we can do with functions is we can pass through variables. So we can say something along the lines of I, and then we can say I, or we'll make it a different variable. We'll say variable equals I plus 3, and then we can say print, and then we can say we want to print our variable. And so in our function, we can pass information through like this. So when we say my function, we can now say input, and then we can say what would you like to add? And because this is a string, we're going to need to make this into an integer. I guess we can go and make it an integer right here, and we can say int, and then we can close this off. Now when we run this, it's going to ask us what would we like to add, and we can say 3, enter, and it'll say 3 plus 3 equals 6. So this is a very basic function. So we take some kind of input right here. This is where we call our function. So now this function is being triggered, but we want to pass something into our function, some kind of variable or some kind of information that we've grabbed somewhere else. And what happens is it can now use this inside the function. This, you may be thinking, like, in what case would I possibly ever need to use this? And so I'm going to just show you my GitHub dumpster diving tool, once again, that I've used multiple times on this channel. This right here, where it's grabbed a repo, I call this function, and it's going to loop through to see every single file inside of the repo. Is it a Python file? Is it a JavaScript file? Is it an XML file? And what happens is when I pass this repo through, it now is able to use this variable that has come from somewhere else inside this function. And then I do the same thing up here. I pass through a variable inside of a function. So this is really important to know, and you will use it. And we're going to go ahead and give another example. And actually, before we give another example, I want you to try and write your own function and see if you can get it to take an input. So let's take the input and make it the first letter of your name. So I'll write out the instructions. You want the, we'll say, first letter of your name, and you want to take this as an input. So we'll say input, and then you want to call a function that adds your first letter to the rest of your name. So here's your instructions. You're going to make a function, and then it's going to take a variable, and that variable is going to be the first letter of your name, and then you're going to add that to the rest of your name. So I hope this makes sense, and I'll go ahead and walk you through what this would look like. So we'll go def my function, and then we're going to call this function. We're going to pass through, let's use I as our variable, so that stops giving us, whenever this is giving us an error and I can't stand looking at it, I type in pass, and that will not give us the error, and we'll come back and delete that in a second. And we're going to call my function, and we're going to take another input, and we're going to say what is the first letter of your name, question mark. Now we can delete this, and we're going to come back up here, and we're going to use this, and we're going to say that my function, and we're going to take this input, and it's going to be a pass through as I. And so down here, we're just going to say my first name is Ryan. So we will say I, we'll call it the variable equals I plus, and then we can put the rest of this inside of a string, and we can say something like this, and then we can print our variable. So when we run this, if I put an R in here, it'll print out my name. So I hope you're able to figure this out. Maybe try to come up with another way to write a function and practice writing functions and see if you can get the hang of it. And in the next section, we're going to go over something that will show you how this can be really helpful in building your own tool. Okay, I hope you have played around with functions and you are now ready to try and become a little more advanced, and we're going to try and gear it towards cybersecurity now. And I hope you're familiar with maybe the Nmap scan and some other tools. So we'll just use an Nmap scan right now, and we'll just say, like, we're going to call a function, and we'll call it Nmap, and this is going to take a variable, and we'll actually call it the IP, because we're going to take an IP address. And the way I like to run my Nmap scans is with they'll look something like this: Nmap -a like this, and then we're going to pass in the IP address, and then I like it to be verbose. Now, in order to get this to run, we would have to import a module called OS, but we're not ready for that. So this is just to show you how the functions will work. And so I will wrap this entire thing inside of curly braces. I got dashes in here that shouldn't be there. I don't know why I did that. And then we'll wrap this inside curly braces. This is not supposed to be inside curly braces. That is supposed to be inside of quotes. We'll make this an F string, and we'll say our variable equals. Instead, this would be an OS command if we were actually going to run this in our Linux machine or Windows, whatever you choose to use as your hacking VM. And now what we'd do is we'd come down here and we would say something like nmap to call our function, and then we're going to take an input and we're going to say, what IP would you like to scan? And then right here we are going to print running nmap scan against, and then we will put in the IP address, and this will need to be an F string. So the way this, that will not be the IP. That will be against the variable. So it will tell us that it is running the nmap scan right here. Okay, so when we run this, we can say who would we like to scan against, and we'd say 192.168 point something else. And then when we run this, it'll print running nmap scan against, and then it gives us the output right here. So this would be a way that if you were trying to write your own tool to automate your recon, this would be one of those ways you would use a function in order to automate your recon. And there's a lot more you can do with this IP address, and you could pass it into multiple different tools, and then you have written your own tool. So this is how we can use functions in cybersecurity that are really helpful for us. And whenever you're going for a certification, it'll be really helpful for you to be able to read through functions and maybe modify them, especially in exploits, because vulnerabilities and exploits change over time, and you will need to be able to change and modify different exploits that you come across on Google in order to gain access to a machine. Before we end this course, I want to give you a little bit of an introduction into making your own tools, and then I want to challenge you to add to this recon tool that I'm about to show you, and you can start to build your own tool for recon, and it'll help you remember the Python code that we've gone over so far in this course. So I've gone ahead and connected to HackTheBox and launched the box devel, and so I want to just show you what OS system does. So we'll import OS system. You've seen this before, and this is just our operating system. It just means we're going to be able to tell our Linux machine to carry out commands the exact same way you would inside of a terminal. So we're going to make a function, and we're going to call it recon, and we're going to pass through an IP address. Really, if you remember, this is just a variable that we're going to be passing through into the function, and then we're going to call our function down here, and we'll just call it recon, and then we're going to ask for an input, and then we're going to say, what IP would you like to scan? And then we'll put a question mark and a space there so that way it's not all smashed together. And now inside of here, what we can do to make this program run our recon and automate it for us is we can type OS system, and then we can put in here, we're going to make this an F string, what we want to do. So we're going to run an nmap scan, and we're going to run it on all we're going to want all outputs. We're going to run it on all ports, and just in case it is blocking the ping, we'll put the P in. You don't have to put this in here, it's optional. And then we are going to put in the IP address that we run through, and I really like to run everything as verbose. So this, when we run this, you'll be able to see, it'll say, what IP would you like to scan? And I'll put in the IP address, and it will now start the scan for us. So this is the same thing we would see inside the terminal. We're going to see port 80, port 21 is open, and at the end of the scan, it will tell us everything that has happened on this scan. Now you can add to this, we'll stop this. You can add to this same scan. When it gets done running the Nmap scan, you can come down here and maybe you want to look for different directories. And so you could go os.system, and we're going to make an F string, and we can add in, maybe we want it to run derb, and we want it to run on the same IP address that we've already passed in. And it will now launch this right here as soon as it gets done with Nmap. And the cool thing about this is if you have your own recon tool set up, you can go ahead and run the program, send over the IP address, and then you can leave and it will automatically run your recon. Or maybe while your recon tool is running, you can do other more manual enumeration. Maybe it has port 80 open and you see that real quick with the Nmap scan, and you want to start looking at what's on port 80, and it will run your Nmap scan, it will run your Dirbuster for you, and maybe you want to run wfuzz, or maybe you want to run sublister. I want you to go ahead and start off with what I have given you right here, and you can add to this tool with the information that you have learned so far.
Okay, so in this video, we're going to be covering enumerating APIs or backend APIs. And I see this in bug bounty programs sometimes, and I'm sure you guys have come across a page that looks exactly like this. You come in, you go to the URL, and you get some JSON in return. And I actually was looking through a bug bounty program just a few days ago, and I actually saw it said backend and then api.theprogram.com. And so if you're new and you're not really sure how to enumerate APIs, then this video is going to be for you. We're going to keep it really short and specific so the way you can go out and do this yourself. We're going to be looking at the box backend on Hack the Box, but we're not actually going to walk through the box. I just want to show you how to enumerate APIs, because this is something that isn't covered in any courses or any certifications that I know of. So if you come in to your terminal and you have an API like this, and you come in here and you type in like V1, or you're typing in basically anything, you're just trying to figure out how do you get further down the line, you're just looking for endpoints. The tool I like to use for API fuzzing is Fuff. So it looks just like this. If I can get here, Fuff, there we go. And I actually ran this just to make sure it was going to work before I did the video. So I like to run Fuff, and then you give it the URL, and this is the API, and then we're going to be fuzzing for an endpoint, and then you give it a word list that you want to use. GoBuster and Derb and a lot of those your usual fuzzing tools just don't work with APIs. So I like Fuff because it does work. And you run this, and you see it pulls down docs and API. So if you were to do this like in a live program, you'd come in here and you just type in API, and then it says we have V1. So you can just type in V1, and then you'll have user, and you can kind of see if we wanted to look for more endpoints, we could just close out of this and we would just move our fuzzer over. So you would just go like this, and then it would fuzz right here, and it would look for more endpoints over on this point. So that's how this fuzzing APIs work. If you're interested, you can go ahead and do the box, Hack the Box. It's actually really simple. You just create a username using the API. So you'll use burp, you'll just intercept the request, and it'll send you back a JSON of what you need, and then you can turn your request into a post request and make a username and password and log in. So this is API fuzzing. You'll see these on bug bounty programs, and sometimes you'll come across them in Hack the Box machines, but this is something that's not really covered. So I wanted to make a quick video on API fuzzing and bug bounty. So sometimes you can find an API URL like this, and you can just start fuzzing away and see what information you can come back with and manipulating the request. So That is API fuzzing. We're going to cover server-side request forgery. The purpose of this video is to show you what is going on inside of server-side request forgery and walk through a couple of examples so maybe you can understand what is happening. So the way we're going to go about this is I'm going to show you a flowchart, and the flowchart might not make a whole lot of sense in the beginning, but I want to show it to you so that way you kind of see what is happening. And then we're going to walk through two different examples and then come back to the flowchart, and at that point the server-side request forgery should make a lot of sense to you, and you should be able to start looking for these bugs as you are browsing through programs, and you'll be able to submit a proof of concept that makes sense to the person who receives your bug report. With that, let's jump into it.
Or with a very simple basic flowchart. I tried to make it as simple as possible so that you guys could understand exactly what's going on and that it wouldn't be too busy with too much going on. So this would be us, the user, and you could also change this to the hacker or the attacker. And so the attacker sends a URL request to the website. So we're manipulating the URL, and then the website makes this request that you weren't supposed to be able to make to the server. And then the server sends the data back to the website, and then you can view it as the attacker. So this is how the flow works. If you were just a regular user, we would just have user here, and you would send a request, and it's just as any request that's going to the website, and the website would pull the information from the server, and the data would be sent back to the website, and you would see the request that the website made to the server. The problem with the server-side request forgery comes in when you have the ability to manipulate this URL request. So let's say it's the URL wants to reach back to the home or root directory, and you're able to grab a file off of the server instead of the actual directory right here. So with that, we're going to go ahead and move into an example. So we are going to be using this example from Love on Hack the Box. I'm not going to walk through all of the recon and what gets you to this point, but rather just what is going on with the URL. So in here we have the web application that's going to reach out to the server through this URL form right here. And if you're ever doing a CTF or any kind of certification and you see something like this, this is a dead giveaway that there is a server-side request forgery anytime you see a URL right here. But most of the time the URL is going to look like this up here, and you're going to have something like this, and then it will pass in a parameter like a URL equals, and then it'll have a file right here such as the root directory or some kind of file. So we could just put in here some file, and then what you would do is you would manipulate this right here, and you could pull down files a different way, but instead of having it right here inside of the URL, this web application has it right here. And because this is an easy box on Hack the Box, that's probably the reason they put the URL request down here in a submit format instead of being in the URL, and you have to deal with it inside of Burp. So this is how you're normally going to see it. It'll be up here in the URL, something like this. And in the next example we're going to see, it's also not going to be up here, but it's going to submit a URL request, and we'll be able to see it in Burp, and we'll be able to manipulate it just like we would up here, only we're going to do it in Burp. So inside of this file scanner right here on this Hack the Box, if you ever want to test a server-side request forgery, it's pretty simple. You can just come over here to a terminal, and you can set up a Netcat listener on port 80, and it needs to be on port 80 because it's going to have to go through the HTTP protocol. Over here, you would just type in something like HTTP right here. This is my VPN with Hack the Box, and so we can hit scan file. It's going to hang for a second, we can cancel it, or you can just come over here and cancel out of this. You can see that it reached out to my little Netcat listener here on port 80, and so we know that this is trying to grab a URL, and you can check to see if it's grabbing a file from the server by typing in the actual IP address. So in this case, for this Hack the Box, the IP address is http / and it's 10.10.10.239, just like this. And if we scan this, it's actually going to bring back the web page right here. So if we went to this IP address right here, we said http, and then we said 10.10.10 239, and then we come here, you'll see this voting system right here. This is also on this server, so I actually had to add this to the Etsy host file, and if you're not familiar with that, what that is, that's okay. So because we're able to pull down this voting system by pointing this machine to itself, we know that we are able to pull information from the server. And I want to show you why this is so bad and it's such a detrimental vulnerability, because if I were to come in here and we scanned and we searched through all of these files like you would in order to get remote code execution on this box, you can grab files off of this server. And in the case of this specific box on Hack the Box, you're able to grab a password file. So you would have to go through and scan the network, but just to show you, we're not going to do that. We can grab, so this is the local host and it's on port 5000, and we can hit scan file. I was missing this dot here. We can hit scan file and it's going to pull this information from the server, and it's going to tell us that you have the credentials for admin right here. So this would probably be the admin, and then you have the password right here. So this is why server-side request forgery is so bad, is you can pull information that you shouldn't be able to access from the file. So we're going to move on to PortSwigger right here, and they have a basic SSRF against a local server. It's going to tell us to solve this lab. We're going to change the URL access of the admin interface at this location, and we're going to delete this user right here. So let's open up the lab, and the way we're going to go about solving this is, I forgot where it told us this is located. I think it said inside of a check the stock feature. So if you come over here and we open up burp, we can turn, actually we need to be inside here. Now we can turn intercept on, and we can check the stock, and we'll send this to repeater, and then we can just turn this off. Okay, before we change any of this, we're going to send this to repeater so you can see what we get back. This is the normal request. This is what we get back. We get back a response of okay. But if we just delete this whole thing right here and we paste in the local host, and then we go to the admin and we send this, we're going to get back a different page, and we're actually told that we've reached the basic SSRF against the local server. And I think we're supposed to actually delete the user Carlos right here. And so the way we would go about doing this, actually before we delete him, I want to try something just because I just showed it. We can go 127.0.0.1, and this should send us to the local host as well. See if we get back the same thing, and we did. So this is what we would do, is you can type in localhost right here, or 127.0.0.1, and then we're on the admin page. Now what we need to do is delete the user Carlos, and I'm guessing this is supposed to be done from the admin panel. I suppose you could read through here and maybe it might tell us what we can do from the admin panel. Oh, it tells us right here. It says we need to delete the user Carlos. So you could actually just copy this right here. Look, it says we can delete these users. It actually tells us we can delete a bunch of users, and we can paste this in here. We got too many admins going on. We can delete that all the way back. Now, if we hit delete, this right here should pop up to solved. So if we send this, it tells us not found. I think we have to follow the redirect, turn the proxy off, and it tells us that we have deleted the user Carlos. So this is how a server-side request forgery works, and I want to walk you through this one more time. So now I want to bring you back to this flowchart right here, and now you understand that what we're doing when we are the user and we make a request through the URL, through something like this, and let's say we want to get a file, you would do this right here. And if you were on a Linux machine, it would look something like this. And you could try and pull down the Etsy passwd file. Actually, I'm not sure if there's supposed to be a colon there or not. So you can Google and check that. I can't remember. But it would be something like this to pull down the Etsy passwd file. And on Windows, you're going to be trying to pull down some kind of Windows system file that would just be on the server to see if you can get files, but you wouldn't do this necessarily in a proof of concept. What you're going to do is, like I showed over here with opening up a Netcat listener and then making a request to the URL, which is going to be your own IP address right here, to see if you get a connection back. A quick tip to see if you're trying to figure out what the server is, if it's Linux or Windows and you want to know what kind of file to look for, you can actually just ping the server and see the Hack the Box is a Windows server and it's 239. Whenever you see this TTL of a 127 or a 128 or something in the 120s, it's going to be a Windows server. And when you ping a Linux server, it's going to be somewhere in like the 65 range. And that's one way to tell what kind of server you're going up against. You can just really simply ping it, or you can run an nmap scan and it will tell you. But this is server-side request forgery in a nutshell. You're the user and you make a request through the URL to the website, and then the website requests the URL from the server and the server sends the data back to the website, and then you're able to view it as the user. And if you are able to manipulate the URL request to the server, you can grab files from the server that you shouldn't be able to access. Okay, so before we move on from server-side request forgery, I really wanted to show you one more thing that you might come up against in the future. So we're here on Forge from Hack the Box, and you have this upload from URL, and I'm not entirely sure how it's going out and grabbing the URL or an image from the URL, because this is apparently a gallery website and you can post images to the website. So we have upload an image. You can upload through the browse like this, or you can upload from a URL. So I imagine it's doing some kind of wget or something like that. And we know that we are on a Linux box, so you can try and do some stuff here. We'll just ping it real quick. So if we ping the IP address, you can see the TTL is 63. So that tells us we are on a Linux box. And so if you wanted to, you could do something like a file / and then we would go etc passwd, and we can try and pull this down, and it tells us that we're not allowed to do this. So we're on a Linux box. We're not allowed to grab files directly from the server this way. So I'm going to put this in burp and we'll play with it in there. So we can, and we know that the URL is working because if we come out here and we set up our Netcat listener like we have been doing, and we put in our IP address, which I have up here, which is 10.10.14.6, just like this. And we hit that, it's hanging, and we see it reach out to our box right here. We can close out of that. So we know the URL is working. Now we just need to figure out how to get the SSRF to work. So we can come back over here. We'll put this in burp and then we'll play with it. So we'll just put in our own IP address right here. We'll turn intercept on and we'll submit this. We can send this to repeater. We can turn that off, and it's going to give an error because there's nothing for it to connect to, but that is okay. So over here in repeater, we have this right here. And if you remember to un-URL encode, it is Control-Shift-U if you are on a Mac. Not sure what it is if you are on a Windows box. So there's a couple of different ways to get this SSRF to work. And I actually want to try something real quick that I have not tried on this box before. I want to see if we can bypass the filter by going file / etc pass wd, and I believe this actually needs 3 right here to work. And so what you see we did here is we saw that it didn't work with just etc password, but it might just have a filter on the box, and if we change some of the casing, it may work for us. And it tells us we have an invalid protocol, so it has to be an HTTP or an HTTP request. So we're not able to just pull down a file because it's requiring HTTP in order to be in the request. We're not going to try and grab the etc passwd file. So what we're going to do now is just try and make a request back to the server and get it to work. So in a bug bounty world, if you come across something like this and you're just trying to prove that you can reach back to the server with a request, what we're going to do is just try and query the server and see if we can get this to tell us something other than an invalid protocol. So if we come in here and we go to the actual URL, which we have right here, which would be forge.htb, and we send this, we get told it is blacklisted. So you're not able to go to the actual URL right here. But if you do like we tried with the file pass, with the Etsy passwd file, you can just come in here and type in forge, and you can just change a few of these characters. And now if you send it, it tells us we have reached back to the server. And we are not getting a blacklisted message any longer. So this is one way to try and bypass like a blacklist or something on a server. And if you come in here and you do a 127.0.0.1 and you send this like we were doing earlier, it is blacklisted. But the actual IP address, so if you wanted to get the IP address of this right here, it tells us that this right here is blacklisted. But if we actually wanted to get the IP address, let's say we're on like Yahoo or something and we want to know the actual IP address of what we have going on right here, Burp will actually tell us what the IP address is really easy. You can just come over to your proxy and turn your proxy on, and for that, and we can come to our URL upload. You can just type something in here, doesn't matter what it is, submit it, and when you hit this, it'll tell us like the request is being sent to forge.htb, but the IP address is 10.10.11.111, and we don't really need that request. So what you can do, since this is blacklisted and this is blacklisted, you can just try the actual IP address to the server, and in this case it looks like this, and you can send it, and you can see that it went through. So the IP address, ironically, is not blacklisted. I'm not sure if Hack the Box meant for that to work or not, but it worked. So you can actually try several different ways to get past the blacklist within a server-side request forgery, and this is a few different ways to do that. Okay, so I think we're going to go ahead and pause on SSRF at this point. If you have any questions on server-side request forgery and you'd like to see something in more detail, please let me know down in the comments. But in the world of bug bounty, this would be plenty to get you by. However, if you're going to be a penetration tester, you're probably going to have to dive into SSRF in a little deeper context. That way you learn how to take a server-side request forgery and turn it into remote code execution. But I think that is out of scope of this video. So we're going to go ahead and pause this here. And if you would like to see more server-side request forgery in the future and how to turn this into remote code execution, please let me know and I'll get to that. All right, before we close out this section here on the server-side request forgery, I thought I would pull up the Hacktivity, and I was reading through some of these recently. And you can just see, look at how high the impact is for server-side request forgery. And I was reading through how some of these were done, and this one right here was really cool. And I thought I would show you how this actually works. And so I went and read through this, and I actually did learn a little bit about the exploit, and it was pretty cool. And I came back to the Portswigger Labs and was playing around, and I found out something I did not know before. So if you come in here where this server-side request forgery is, and you remember it's right here inside this stock API, we can send this over to Repeater, and if we do the unURL encode it, we have this right here, and we can see what's being sent, but we'll go ahead and put that back. But what you can do that I didn't realize we were able to do is you can just add in another parameter. If we were like breaking this right here and it wasn't working, we can just come in here, put the and sign, and type in stock API equals, and then we could just do the local host. And then we can go /admin because we're supposed to pull down the /admin panel, and we can send that, and we need HTTP // and it works for us, and it pulls down the information we needed in order to delete the user Carlos. So I didn't know beforehand that we can just add in new parameters right here. And so I thought this was something that was really cool, that you can add in extra parameters in here in addition to the one that's already there. So you don't actually have to delete this first one. You can just pull down pull down a second one, and then also reading through the Hacktivity, I noticed, I think what we'll do is just delete this first one so that way it looks nicer so you can see it. And so we'll send this and we don't get quite as big of a page back. When you're doing something like searching for an SSRF, I noticed a few of the Hacktivities they had hit a line like this that's accepting in a parameter, or even up here in the URL. And what they just started doing was they would say, and URL equals, and then they had put in 127.1, and then you could just leave it like that, and they were sending this. And it would be easier to test for this if you had it in repeater. So we can grab this, send it to repeater, not sequencer, send this over, turn that off. And then if you send this, you'll see it doesn't actually pull anything back for us. And you can search for the word delete over here as if we were going to delete the user, and there is nothing. But you could search, you can try this URL, you can try URLs and send that to see if this is a parameter that will actually reach out to the server. Usually it's going to be saved as a URLs or a URL, something like this. And this is not vulnerable. This actual lab is not vulnerable with the URL parameter because the URL parameter is not the one that's making the request out to the server. But you could very easily change this with a change the request method, and then delete this and just add in the stock API just like this, and this should work. I think we have to make it so it says it needs to go to the admin panel. It needed this up here, products, and then in the stock directory, and I forgot HTTP // So basically this is just remaking this request over here, but this should work now, and it does. So you can play around with these when you're in a live program and see if you can find a parameter that actually does hit the URL. So if you come over here and you open up this and you're reading through it, what's really interesting inside of this guy's explanation is there was actually a notification that says this right here is reaching out to the URL parameter, which just pretty much tells you that it's going to be vulnerable to a server-side request forgery. And when he tested it right here, it works. Now this guy had to do a little more to it, and I don't want to read all this to you, so you can come out here and read it, but he had to do a little bit more in order to get this to work through a token, I believe it was. But it was a pretty cool server-side request forgery, and you can come over to the Hacktivity now that you understand how server-side request forgery works, and you can read through some of these and see if you can learn additional ways to pull off server-side request forgery. So with that, I'll see you in the next vulnerability.
All right, welcome to the section on command injection. This is probably going to be one of the most severe vulnerabilities that you will ever come across. This vulnerability gives you the opportunity to execute commands on the server and get information back, and possibly even get a shell on the server. So this is one of the most severe vulnerabilities that you will probably come across, because you can just compromise the server and all of the information on it. And if you're in a penetration test, then you can try and move around within the network. So let's go ahead and dive into command injection.
Okay, we are going to be talking a little bit about command injection, and there's not really a whole lot of places to practice command injection that I know of. Really, it's just TryHackMe and then PortSwigger, which we'll come to here in a little bit in practice on. So with command injection, what we are able to do is put commands into the server, and then it tell us back. It'll give us the information back for whatever we sent the command in for. So if we send a who am I command, it will tell us who we're running as on the server. And so it says here, a command injection vulnerability is also known as remote code execution because an attacker can trick the application into executing a series of payloads that they provide without direct access to the machine. So this might sound a little confusing, but it's going to make a lot of sense here in just a second. And so their example here is the whoami command. And I'm going to go ahead and launch this box. And then once it is loaded, I will bring you back. Okay, so this is now loaded up and ready for us to practice some command injection. But before we do, I want to show you kind of what is happening. If we come over to a terminal here, and the first thing I want to do is copy this to make sure we know what kind of commands to send through to the server. But really, you could just put in an who am I, and you could probably figure it out by that. But we can also type in ping and then the IP address that we just copied, and then you can hit enter and we see that the TTL is 61. So we know that this is going to be a Linux server that we are up against. So now it tells us to use this handy web application to test the availability of a device by entering its IP address, and it's just going to go out and reach to an IP address. So a way to test this is to see if we wanted to check our device. We could come over here and set this up, and my IP address is up here, so we could say 10.2.42.96 and execute and see if we can get it to reach out. And it sent a ping out to our box, and it did not connect, but it pinged our box. So this is just sending a ping. It's not actually trying to connect. So what we can do with this now is you can just type in 127.0.1 and you can execute it, and it's going to tell us, it's going to give us back another ping of the box. And I guess I didn't need to ping it because it tells us right here it's going to be a Linux box. So some of the things we can do, I actually played around with this. That's why you can see these in here. I wanted to see all the different commands that it actually let me send. So I wasn't just sitting here testing everything for the first time. So here's a couple of the command injections that you're going to need to know. If you come in here and we type in 127.0.1, you can do an and sign like this. 0.0.0.1, we can put in an and sign just like this, and then we can do a who am I, and it'll execute. And you can see that it says we are www data, but we still get this ping right here. And it is possible in the coming lessons that we just don't want to see all of this ping right here. So what you can actually do is just put in a bunch of mumbo jumbo, and then you can use a double pipe and do the who am I, and it skips the ping and we get the www data. But if we run this command right here and we don't double pipe it, you only do one pipe. Oh, it still works. Okay, I was going to say that it doesn't work, but it worked for us. So we still get the www data. So sometimes it won't work with one pipe, and you'll want to send through two pipes, and then sometimes you'll also have to have like a pipe afterwards and run it, and that time it doesn't work for us. So you will in the wild just have to play around with this. So we get the who am I, and it tells us we're www data, and you can type in ID and see how we're sending commands through. So if we come back over here and I type in ID, you can see we get this back. So we're actually communicating with the server, and this would be a very, very bad thing in the real world. So there's one more thing I wanted to show you, and that is this ping right here. If you were doing a blind command injection and you wanted to know if you could reach the server but you weren't getting any information back, you could run the regular whatever's up here. Sometimes it's not going to be something like this. You're not going to be pinging a server. It'll usually be a parameter with an equal sign, and then you put a command in over here. But you can ping, and the -C with the 10 is going to tell it to delay 10 seconds. So we'll actually put in 5 seconds so we don't have to wait quite so long. And it's going to ping itself. So if you watch down here, we have the seconds, and we'll hit it when it hits 10 seconds and wait for it and see if it comes back in 5 seconds. If so, then that works, and it did. So we pinged it, and that's how you do a time delay, which we're going to see in just a little bit. You can also run these with this and sign right here. There will be times that you'll need to try this, and you can actually, if you're getting stuck on command injection, what you can do is go out to Google and just type in command injection bypass and just look for different Windows command injection bypass. Maybe you'll have to do some URL encoding or something of that nature, and you can just bypass whatever filters they have. So you can also do with this, you can do two and signs just like this, and it should still work for us. And we'll send that over and see if it takes 5 seconds and it comes back. And then I want to try one more thing. I actually have not tried this yet, but because this didn't reach back on our Netcat, I want to try this again. We'll set up a Netcat listener, and we're going to set it up on port 4000 and see if we can actually get this to connect back to us. So if we do this right here, we can do our pipe. We'll actually do a double pipe, and then hopefully we have Netcat available, and we can type in our IP address for it to connect back to. So 10.2.42.96, and then -E, and then we'll go bin bash, and then we can execute this and see if it reaches back. It doesn't look like it's going to because I did not type in the port. So we'll highlight this. We need to put a port in here, and I think I did 4000. Execute. It was port 4000, and it did not reach out, so maybe this doesn't work. We'll try one more time, and then we'll move on. And I want to show you one other thing you can try with this. So Netcat doesn't work, didn't reach out to us. So one thing you can also do in this command injection, like if you were going to capture the flag, one thing I would do is I would come in here and I would type which Python and see if we could get a Python reverse shell. And we can close out of that. And let's do something like this so we can get just what we want back. And we don't have any output. Let's see. So this box might not let us get a reverse shell on it. So I guess we're not going to be able to figure out what kind of Python's on here. But this would be command injection in a nutshell. And I'm guessing we have Python 3. So we could try to get a reverse shell with Python. So you could come to Google and we would type in Python reverse shell. We can try Pentest Monkey. And we could try this right here. So we can set up our Netcat listener. We'll go port 444. And we can type something in here. We got bin. I want bin bash. What do we have over here? And it's possible that this won't work either. And I would suggest typing something out like this in a text editor. Save some time. 0.96, and make sure this says we need Python 3, execute, and we get a shell back over here. So now if we say who am I, we are on the box, and if we type in ID, it'll tell us who we are. So you can get a reverse shell this way rather than just be sitting over here with command injection. And sorry, I kind of fumbled around there. I actually didn't try that before we did this little video here. So this is command injection in a nutshell. This is a great place to practice. So if you have a subscription to TryHackMe, this is a really good place to come over here and practice your command injection. But if you don't, there's also a free way to practice command injection, and we're going to practice it here in just a second on PortSwigger. So let's go ahead, and I'm going to get things set up, and we will start command injection over here in PortSwigger. If you would like to go ahead and open up PortSwigger and get this set up so you can follow along or try them on your own, then you can do that. Okay, so here we are at Portswigger, and we are on the OS command injection. We're going to do these first 3 right here because they're pretty easy, and I believe you had to have Burp Pro for this, and so we're not going to do these ones down here. But the first 3 of these are actually pretty easy, and you should be able to, I think, solve them. I think you probably could solve all 3 on your own, but for sure you should be able to solve these first 2. So we'll go ahead and open this up. And it tells us this lab contains an OS command injection vulnerability in the product ID checker. The application executes the shell containing the user supplied product store ID. So we've seen stuff like this in the past. So we'll access this lab. And it tells us we are not solved because we haven't done anything. So when we have finished this should say solved up here. So we can see what Burp is doing. It's doing nothing. It's not hooked up. So down here in the check stock, like we've been doing and following the instructions right here in the product stock checker, we can forward that. We're going to check stock, forward, and right here is what we need. Send that to repeater. We can turn that off. And now we have the product ID and the store ID. And this is going to be where the command injection is at. So if you would like to try and solve this command injection by yourself, I would go ahead and give you this challenge. We have found the location, and I think you can figure it out. It's right here. You should try and see if you can figure out some of the command injection commands that you just saw previously and give it a shot. But if not, here we go. So we have this product ID right here of 1, and what we were doing in some of the last ones was we were able to put this and sign in here, but because of the location of the command injection in this post request, we're not going to be able to use those. We will have to use a pipe. And so you can type in a pipe right here and do something like a who am I, and we can send this and see what happens. And it tells us who we are. So that probably right there solved this for us, and it did. But while we're here, let's play around with this. Let's see what happens if we do 2 pipes and we send this. It does nothing. What happens if we do 2 pipes at the end and send it? Nothing comes back. What happens if we just do 1 and 1? And this is just something that I would encourage you to do as you come across things like this. So we actually have it come back with a pipe at the end and the beginning. What happens if we change this to very clearly a product ID we don't have and it still works? What happens if the product ID is wrong and we have 2 pipes and we send it? Nothing. Now, what about this store ID right here? What if we try 2 pipes and we go, who am I? It gives us a syntax error. What about 2 pipes? And we send it. It gives us the same thing. We can come over here and maybe we can say an ID. It tells us who we are. And so you can really just play around with this and see what happens. What if we put a crazy ID number in here? It still works. And then you can just mess around with this and see what works and what doesn't. If we check a who am I, syntax error, we could go which Python like we did before, and this is black because it needs to be URL encoded, which is a plus sign, and we don't get anything back. And I don't think that you're able to get remote code execution on this. So here we go. This would be your command injection right here. We're going to try and do another one on this lab right here. So if you would like to go ahead and open this up and read the instructions, then I would say go ahead and see if you can figure this out. I'm not going to read it just yet. I want you to go ahead and read this and try and figure it out on your own. And if you get stuck, then we'll go over it. Okay, so this says the lab contains a blind OS injection. So if you're familiar with the bug bounty for beginners course that I already have out, then we know that a blind injection means we're going to have to do some kind of time delay, and it's not going to tell us what's in the response. So we have a 10-second delay in order to solve this challenge, and it tells us that the vulnerability is in the feedback function. So with this, you can go ahead and open up the lab. And we have this submit feedback right here. And we can just type in a bunch of gibberish. And I think this is going to ask for some kind of ending for an email account. And we can come back and intercept this. Send it. We'll send this to a repeater. And it is possible that this took you much, much longer to figure out because we have a bunch of different parameters in here that we are testing against. So we have the name right here. So in a time delay, we saw this in the try hack me example that I showed you. You're going to try and do a ping against the server itself and wait for the time delay. So what we would do in a time delay command injection or a blind command injection with a time delay, you will type in ping, and then we have to URL encode it, and it will look just like we did previously. I'm going to do 5 seconds to start out so we don't have to wait. 27.0.0.1. And then if we send this, we'll see right here, this should be like 4,000 or 5,000 when it actually works. So we can try a pipe at the beginning, pipe at the end. We can try another pipe, and I see that I made a mistake. I didn't have the 1 in there, so we'll try this again and say go. Still not long enough. We can add in another one and see if this works. And it doesn't seem like this is going to be our spot. Otherwise, one of these would work. We can't use the and sign in there, so we'll just move on to the next one. We'll say pipe, ping. And I have this, I fast forwarded typing this in so you didn't have to watch it again. So we got our pipe and our ping command. We can send this. We'll turn this proxy off. It's bothering me that it's flashing. We can see that the time did not work. So we can throw a pipe on the end. Send it. Not long enough. Let's try 2 pipes. And we can send it. And our time is much longer, and we can see that it was almost 5 seconds. So now to solve this, I believe we can type in a 10 right here and send it. And this should give us the solve because the 5 seconds was pretty close. So it's not solved. And it just came back, and it tells us that it has solved. So this is a timed command injection or a blind command injection. This is how you would test it with a ping against the server itself and give it a time delay. So with that, we're going to move into the last one of our command injection labs. This one is going to be a lot harder. I think you can figure it out if you've done my bug bounty course and you've also gone through my free ethical hacking course, because the ethical hacking course is going to cover things that are kind of like this when you get into the actual penetration testing portion of that course. So if you've gone through both of those, I think you can solve this. If not, and you're pretty new, you're probably going to struggle with this one, but we'll go ahead and solve it anyway. So we'll open up the lab in a new window, and then we'll read what it says. So it has a vulnerability that is blind in the feedback function, just like we had before. The output is not returned in the response like before. However, you can use the output redirect to capture the output from the command. And it says that we have a writable folder. And then it tells us to solve the lab, we need to execute a whoami command and retrieve the output. So what we're going to end up having to do is send a whoami command to the server, and then we're going to have to save it in a file inside of this images directory. So it's going to be var www images and then the file with an output. So if you went through the ethical hacking course, I think you can solve this. If not, we'll go ahead and solve it together now. So I just had an idea. If you want to try this on your own, I can actually show you over here. We can make a directory and we'll call it test. We'll cd into cd to test. And then what we can do is if I type in who am I can send this command and I can put it in a file.txt. And now if I hit enter and then we will ls, you can see this files here, and I cat out file.txt. It tells us that we are Kali, or if I gedit this file, it'll save the response in there. So we're basically going to be doing this right here inside of this directory right here. So what we're going to do is give a who am I like we did up here, only it's going to be in this right here. And so your command is going to look like this. And if it has to be URL encoded, you'll need plus signs right here. If not, you might be able just to delete this and do it with no space. And then you're going to need to try and retrieve the file with the command injection. And I want to see if you can figure this out. So go ahead and give it a try now that I have given you a hint with this clue right here. Okay, so let's go ahead and solve this challenge. It said it was in the feedback. So we'll come back to the proxy. We can come to submit feedback. We'll do the same thing we did before and just type in some mumbo jumbo at gmail.com and turn our proxy on. Submit feedback, send this to repeater, turn the proxy off. And so here we are at this same page we were at. I'm actually going to make sure that this is in the exact same, the command injection is in the exact same place, so we don't spend a bunch of time trying to send this somewhere that it's not. So we'll go ping. So I wrote the ping command out so you didn't have to watch it. I sent it, and we'll see it was a 5-second delay. So the command injection is in the same place. So we should be able to come in here and say, who am I? And then we'll give our caret, and then we'll give it the location that we were supposed to give it right here. Paste that in, and then we'll say file.txt and send this and hope that it worked. And now I think the way to check this is going to be, we'll need, I think it'll be file, and then we'll want to read this file.txt. So we'll send this. Okay, since this right here isn't working, we're going to just go ahead and assume this is not going to be in the right directory. So what we can do with this right here is we know we had to send it into the var www, and then I think it was images, and then it was our output.txt, which is where we, and then it was our file.txt, which is where we put our command who am I, right? That's what it says. We do, yes, it's in the images. So what we're going to probably have to do at this point is find the images, because we're not able to pull anything from here. So what we'll do is go to the home page and see if we can pull an image somewhere around here. See, we have the products, we have the product ID. We have the image. Okay, so we right click the image and hit open image in new tab, and we have the image, and now we have a file name. I bet we can do this without burp, and then if we can't, we'll open it up in burp. So we'll type in file.txt, which is where we put the file, and it tells us who we are as the user. So that's one way to solve this challenge. It was a lot more, this one was a lot more difficult of a command injection. In the real world, you wouldn't do anything like this. The only time you're going to do something like this is in a CTF. Or if you were on a live pen test. In the real world, in a bug bounty, what you would do is probably just send a ping with a time delay and then submit that, and you would stop right there. But because this is a CTF, it wanted us to grab this user right here, and this is where we did it. We saved it in images, and we needed the file name and the file.txt. So that is the last of the command injection that we're going to be covering, and we'll move on to the next vulnerability.
All right, in this portion of the course, we're going to be covering file upload. This can be a severe vulnerability, especially if the file is placed somewhere that you can execute what you have uploaded and get back a shell on the server. So file upload is one that you're going to see a lot in CTFs. They do happen in bug bounty programs. You can go and read on the Hacktivity about some file uploads, but in the world of bug bounty hunting, most of the time they're probably not going to lead back to a shell. But in the world of penetration testing and CTFs, or if you're going for any kind of certification to become a penetration tester, then file uploads are always a good place to look, and make sure when you're uploading a file to see if you can bypass any of the filters that may be keeping you from uploading a specific file with a payload inside of it. So with that, let's go ahead and jump into it.
To the file upload. So we're going to be going through a few Hack the Box file uploads, and the reason we're going to be doing Hack the Box is there really is no great place to practice file upload, and Hack the Box really has the best systems to practice file upload. If you have a Hack the Box subscription, then you can open these up, you can play around with them yourself and actually test these out. If not, in the world of bug bounty, if you go to the Hacktivity, you can read about file uploads happening all over the place. So file uploads do happen. We're going to start really basic, and then we're going to have to go through bypassing different filters within the file upload. So this one is really one of the easiest, and if you want to, this box is called October with Hack the Box, and its IP address is right here. And I'm not going to show you how I got to this spot, because really we just want to see the file upload in action and what happens and why this would be a really huge vulnerability in the penetration testing world. So the first thing we're going to do is we can click this file upload, and I tested it. You can upload a file right here. And so what we're going to do is we can just click the file upload button, and I'm going to show you two different ways to go about uploading files and testing this out. So the first is with a web shell, and what we can do is we can come over here like we did before. And what we can do is we can go to Google and just look for web shells, and I can just show you right here. I just typed in web shell, and I scrolled down until I came to the Shushan 747, clicked on it, and we're brought to some PHP web shells. This one right here is one of my favorites. It's the one I use the most. And we can just say that we want to create a gedit, and we'll call it web.cmd. And sometimes you might have to name this like PHP if that's what this server's running in order to get a web shell to run. But we're going to run with CMD, and we'll test this out. We may have to change that to PHP, I'm not really sure. And so we can come back over here. We can upload our web shell just like this. And if we go to the URL, this is a good sign that it didn't give us an error. Now we had to pass in a parameter because we have this right here. It's going to call our web shell when we pass in the parameter CMD. So we can come over here, go $CMD equals, and now we should be able to type in a command here. And if our web shell works, we will receive an output on the page. So we can type in who am I and run it. And this doesn't seem to work. So we will rename this. We'll just go move. So we will type in our web shell, and we will just move it from WebCMD to WebPHP5. And the reason I went with PHP5 is because right here, I should have saw this the first time, it says PHP5. So we can save this, and now we can upload, and we'll re-upload our web shell just like this. And now we can click on it, click here, move that out of the way, and we can put our parameter in here. So we want a CMD who am I. And now it tells us we are www data, and you can use this right here to try and get a reverse shell back over here. But I think what we will do is we will just use the Pentest Monkey PHP reverse shell. So we'll just say PHP reverse shell, and it should be the first one. And so what you can do is go to raw, Command A, Command C. We will come over here, and we will just say gedit, and then we'll call it shell.php5. We can paste this in, and then we'll need to change our port because we're listening on port 444. And over here, we are listening on 10. My IP address is 10.10.14.6. We can save this, come back over here. We could probably close that out. We'll upload this file. We want our shell open. And then we click this right here. It hangs, which means we probably have got our callback over here, and we now have a shell on our box. So I want to explain what is happening now that you've seen this. The way a file upload works. If you upload a file, you have to make sure that you know where the actual file is being stored, because when we upload our malicious code, if you can't execute it on the server, it does you no good. So let's say you can upload some kind of shell like this web shell right here or right here, but you can't find the location on the server of this web shell to execute it, it does you no good. So you have to be able to locate it. And for us, this is a really, really simple file upload. You just click here and it takes you to the location right here of where our file is that we uploaded. So this is a really simple file upload, and we have this right here. It tells us it's running PHP. Sometimes it'll just say like we'll have a backend. It'll say something like backend.php like this, and then you'll know it's running PHP. Or if it's Windows, you may try ASPX or ASP. And so you're just going to have to get familiar with the systems you're going up against and what you see on the server that you're attacking. But this is a really basic introduction into a file upload. We're going to do a couple more that are going to be a little more challenging, which is also going to be a lot more realistic. In the real world, the chances you just come across something that just says file upload in a bug bounty is almost zero. Maybe on a penetration test it might happen, but in the world of bug bounty, probably not going to happen. You're going to have to bypass some sort of filters, and we're going to do some pretty simple filter bypassing in the next file upload. All right, we are here on the Box Popcorn. Same thing, I'm not going to show you how to get here because we're just covering file upload. And in this one, we're going to talk a little more about bypassing different filters. So if we come in here, we have this edit right here, and it tells us we can update the screenshot, which is going to be this image right here. And it tells us it allows a JPEG or a PNG. And I've never tried JPEG, so we might try that just on the fly and see what happens. But we can save this right here. We can go save image as, and we're in our test file right here, or test directory. So we'll save that. And if we come over here to update the screenshot, we will need to browse, click on our little PNG right here, update it, and submit. And it tells us that it worked. The type was a PNG. And now we should be able to come over to the uploads. We can type in 10.10.10.6 and we'll go /torrent, and then we want the upload just like this. And it tells us here is the image that we just uploaded. So that works. So what we will want to do now is see if we can upload some kind of shell. So we'll just use one of our PHP shells that we already have in this directory. And we'll browse, and we can just try this shell.php5. And if we open this and we submit it, it tells us we have an invalid file. Let's come over here and we will move our shell.php5, and we'll just call it shell.php. And we can try this. And it says invalid file. Now what we can try and do is intercept the request and see what the difference is between these. So if we come to update this, and we want to update this image again, and we upload it, and now we turn our intercept on and we submit this, we can look at the difference, and we'll send this to Repeater just to save it. And we know that this is going to go through, tells us that it worked. Now we'll come back and upload our PHP shell and see what the difference is. So we can come over, we'll try our web shell this time and turn on our interceptor, send it, we'll send that to repeater, and we can turn this off now, and we can come over to repeater and look at these and see what the difference is. So when you come over here and you look at this, right here is what we're looking at. So we have a content type of image, PNG, the file name, which was the link that we downloaded, and then it tells us it's a PNG file, and we have all this mumbo jumbo right here. And so what we can do is just copy some of this, and we can copy, and then we can come over here and we have a file type of web.php, and then we have our little web shell that we used before, and we could just paste this in up above. And so our content type has now changed, and we have these bytes to try and confuse it. And then we have this image, or we have our web shell right here. So I want to show you a little bit of how a server would read this file type. If we come in here and we just say gedit, and we want to make a we'll make a file.gif, and we'll see what happens. And we'll just put in some letters. And we save this, we close it, and we go file, and then we say file.gif. It tells us that it is actually text. So if we then come into our file.gif, there is something called magic bytes that we can add in here to try and trick it. The way a GIF starts is with a GIF 89 or 87A, and if we save something like this and run file on it, now it tells us we have a GIF, an image type, and the version. So this is how a server would read this. If you upload something, it's going to run something like a file on it to see if it really is a GIF or if it just has text in it. And so when we copy all of this right here with the PNG, basically what we're trying to do is trick it by putting something in like this GIF 87A, so that way when it reads it, it will read it as a PNG. And we'll actually try this GIF because I've never actually tried it on this box, so I don't know if it will work or not. And we'll just try the file upload on the fly. So if we send this over, it tells us that it looks like it uploaded. So we can see what it looks like. It did upload. So I'm kind of surprised that worked. We'll go check it out. So if we come over to our uploads, we refresh the page, and we open this up, it looks like it worked. We should be able to pass in our parameter of cmd equals, and we can say who am I, and it tells us right here www data. So that actually worked. I was expecting it to not work, and sometimes when you hit a file like this and it does not work, it might check for just a .png inside the file and then the .php. And if you just go out to Google and you read about different ways to bypass filters for file upload, you're going to have a lot of information, and that's really what I would recommend you to do. This is just the tip of the iceberg on how file upload works. So I'm just showing you some basic ways to bypass it, but I would also recommend going out to Google and reading about how to bypass a PNG file upload filter or a JPEG and see all the different ways you can bypass this. So if we come in here and we send this and it renders, it tells us this worked as well. So we can actually go back, and if we refresh this right here, and it tells us that this worked. So there's one other thing. Let's play around with the JPEG. So if we come in here and we close out of this, let's actually just play with it in repeater and see what happens. So if we say it's an image and we say, actually let's try the GIF because we already have that set up, and we just leave this like this, and we delete all of this, and we just type in the 87A with GIF at the front. Let's see if this works. It says invalid file. So let's take our PHP shell. We'll copy this, and let's see if we can just say, let's gedit this file, and we'll call it file PHP, and we'll add in the GIF 87A. And then we'll put our PHP in here and we'll save this. And then we're also going to need our GIF file. So we have that in there too. So that way we can make sure that our content type right here is right. So we'll go to proxy. So that way it is ready. We can try this upload, browse. Let's upload the file with the GIF. We'll open, make sure that we catch this, send it to repeater. It looks like that is how it goes. I actually want to turn this off. It says that it worked. Okay, so it does accept the GIF as well. Now let's upload our reverse shell that we saved in file.php. And we'll send this on over to repeater. See how we have this application type is different. So we can turn this off and see if we can get this to work as well. So we'll send this and it says invalid file. And when we send this, it says that it worked. So what we can try and do is just grab this like we did before. We'll copy it and paste this in. Should be able to delete this. Does that actually have a semicolon in it? It does, so should work like that. If we send it, it says that it worked. So let's go see if we can find that. Here's the GIF. It says it didn't work. That's not surprising because it's not actually an image. We need our other PHP shell. Here's our GIF with our PHP in it. So let's try and pass in the same parameter equals who am I, and if we send this, it tells us this GIF works and it cannot execute the command within the file. Let's try and just delete this and see if we can get a who am I this way. We'll send that, come back, refresh, check out this PHP, and it tells us we're www.data. So it does let us inject a command with a GIF, but for some reason I wasn't able to get the web shell to work. But there's another way to go about this. So this would be a really roundabout way to do this. You could come in and we could try and upload like a Python shell in here, or because we know we have PHP, we could put inside of here, and so we could put inside of our command right here, instead of doing a system who am I, we could come to this web shell and we could execute a PHP reverse shell like this. But you saw us use this recently. Let's just try and upload this PHP shell and see if we can get this to execute a reverse shell for us. So we'll come back over here. We can edit this again. We'll put in our PHP reverse shell. We can open. We'll need to catch this inside repeater. Turn our interceptor on, submit, and send over to repeater. We can turn this off, come to repeater. It tells us we have an invalid file, which we expect. We have the shell.php, and we'll just use the one with the PNG because we know that it's going to work for us. So we can come over here and we can just highlight this, paste in the PNG. Now, if we send this, it tells us that this worked. We can set up a Netcat listener over here. Netcat, and I think we originally made that on port 4444, and now that's listening. So now when we open up that file, it should execute on the server and it will give us a shell back. We can see our PHP file, we can see the size has changed. So we open this up and it's hanging and we have a shell return back to us, and it's going to tell us I am www.data. So that is file upload. So there's a bunch of different ways you can play with this. If you have Hack the Box, I would recommend coming into Popcorn because you have a lot of different ways to play with this. You have the JPEG, and the GIF, the PNG. And so you can just come in here and play around with these and see all the different ways you can get a reverse shell from a file upload. And I would recommend, because we were not able to get the GIF web shell to work, you could play around with that and see if you could get a web shell rather than just executing commands one at a time. And then maybe see if you can get a reverse shell from the web shell, because there will be times that you have to do that inside of CTFs. But in the world of bug bounty, you really wouldn't be trying to get a reverse shell. You could just simply do a web shell and a who am I for a proof of concept. And file uploads are something you're going to see, so you can read about those in Hack the Box. And I would definitely recommend going out to Google and continuing your research on file uploads. But like I said, there's really not a lot of places to practice file upload, and it's because if there's a file upload that is going to be vulnerable on a server, you can get remote code execution. And for this reason, Hack the Box is really the only place that is really good for file upload. TryHackMe has a little bit of file upload, but I don't think it's as good as Hack the Box when it comes to practicing this specific vulnerability. TryHackMe is really great in other areas, but Hack the Box is really good for file upload. So with that, I will see you in the next vulnerability.
Okay, welcome to the local file inclusion and the remote file inclusion, also known as LFI and RFI portion of this course. The LFI is going to be one that is more common than the RFI, and the LFI is going to give us the opportunity or the ability to read local files on the server, which could lead to a compromise of sensitive information or data that we're not supposed to be able to access, and files on the server that we should not be able to access. The RFI is going to give us the ability to host up our own files and then have the server reach out to our server that we make on our Kali machine and then execute that file, and will lead to remote code execution on the server. So we're going to jump into the LFI and the RFI now. Let's get started.
Welcome to the LFI RFI, so the local file inclusion or the remote file inclusion portion of this course. We're going to be using TryHackMe for our example, and TryHackMe is just too good to pass up when it comes to practicing LFI and RFI. If you can afford a TryHackMe membership, then it is worth it just to come in here and practice your LFI and RFI along with other things. And when it comes to Hack the Box doesn't have any really good place to practice and RFI. So sadly, if you have only a Hack the Box membership, you're not going to be able to practice this. So what we have going on right here, this is a really great explanation. I'm really happy with how they have this all structured. So you have your basic web application right here. You have the HTTP, the URL, and then you have a get.php. And this PHP right here is going to be a giveaway of the way we're going to go about trying to pull this file down. So oftentimes you're not going to see a .php, but sometimes you will. And when you see a .php and then a file equals, just like this, you can think you can try for an LFI. And we've already talked about directory traversal. And typically if something is vulnerable to a directory traversal, you are going to be able to pull down files